just regulators, you are enablers of innovation, guardians of public trust.
Yes.
Oh, hi guys. Hi guys. Uh, Nice to see you all. My name is Joseph, and I'm a software engineer here at Qhala, and we're going to be starting in the next few minutes. So get ready to discuss about compute. So we just like in the next what's the time now? Yeah, so we're just waiting for a few more people, and then we'll get started. Thank you so much for coming.
Good morning, everyone. Hello, hello. Thank you so much for waiting. And we would like to welcome you to our office here in Qhala. My name is Wanji Romboro. I head the research team here at Qhala, and we are privileged to have you all here. For those who don't know Qhala, it's a digital innovation company that is pushing the digital in Africa. And in this era of AI, that is our focus area. How can we allow or enable Africa also to play part in this AI era? And one of the key things that we have done, we played a role in developing the Africa AI declaration that was launched in March during the AI Global Week. And what does this declaration push for? One thing is to see that we are developing tools that will support our Africa people. Data sovereignty is also a huge thing that we are looking at. And also the last thing is to see how can we make computing affordable. And that's why we are having this watch party. We are looking at ways that we can make computing affordable. We all know computing is an expensive venture, especially when it comes to AI development and launching of AI tools. And we are looking at ways that we can make computing affordable in Africa. And that's all the conversation here. So we welcome you again. There will be a panel, there will be conversation. NVIDIA CEO will be speaking to us. So stay put and karibuni tena. I would like to invite our MC of the day, Mr. Karaoke. He's the CEO of Fastaga. Karibu Karaoke to take us through.
Thank you very much for the intro. And well, maybe one day I'll be doctor. Hopefully, no, but one day, you know, when people say such things to upstairs, maybe it'll happen. So thank you very much for the introduction, and thank you very much for everyone who was able to make it here today, and for all the people who are there online. Of course, all of us here are, you know, very much interested in machine learning, AI, and we all know the challenges when it comes to, you know, right now the world is divided into GPU poor and GPU rich countries, right? Literally, you know, in terms of even try to get a GPU from NVIDIA right now, and there's like a long list, you know, an A100 or H100. So, you know, this is a big topic. If we are actually going to build solutions that actually work for us here on the continent, then it's going to be, you know, a big challenge. I think all of you probably have seen the news yesterday that Scale AI was, you know, just 49% of their equity was bought by Meta, you know, for I think almost $15 billion. So, you know, everything is just congregating really to the West, even the tools. And so the question is, how are we actually going to be able to also participate in this economy of AI? And this is the whole reason for this watch party. And so it's going to be a very interesting conversation that we're going to have. The panel is, you know, people who have built solutions, deployed solutions, Dr. Betsy and others, you know, Andrew from Safaricom, people who have actually been building solutions and deploying them, right? I myself, again, introduction, Tembe Karik is my name, CEO and co-founder of Fastaga. And what we're essentially doing is actually building distributed AI platform that can be able to run machine learning on the kind of devices that we have in Africa, particularly the kind of techno smartphones that we have on our continent for different solutions. So just before I end up talking too much, I'm going to hand over to John Weiner. So he's Joseph, sorry, who's going to take us through a bit of a background of the conversation today. Joseph.
Thank you so much. And, you know, when I was preparing for today, there is one thing that kept on lingering in my mind. So, you know, as Kenyans, we now call ourselves cousins. So I'll start with that. Hi, cousins. Hi, cousins. Hi, Makuzo. And I think that's the spirit that we are trying to take into compute. So we are trying to have a conversation compute for Africa, and we want to start like a small Kawamunyoro in Qhala, Nairobi, Kenya, and then we can invite our fellow cousins. So we can go to South Africa, we can be able to take the conversation outer. And we're trying to see how can we be able as Africans to consolidate our own compute needs. So how can we ensure that our data is stored within our own servers? We can be able to control our data sovereignty. So for all these babies called AI that we're trying to train, how can we ensure that they are born in Kenya? So you see, if you have like a baby and then they have been brought up in a different culture, they won't like really fit into your culture. And we're trying to see if you can be able to merge, like have like a village that will be able to raise this baby with our culture, with our language, with our data, so that it can be able to work for Africa. And we've been working with DCP. So I'm waiting for Martin to help me start presenting. So we've been working with DCP, and we've been looking at ways how we can enable researchers, how we can be able to enable fast researchers, we can be able to enable corporates, we can be able to enable any university in the world so that we can bring all their unused resources. So for example, if you're in a university or if you went to university, you know that they have huge computer labs. So these computer labs, they have like 8 GB computers that are not that powerful. When it's alone, it won't be able to do much. But if you can be able to combine like 10 of them or 100 of them, we can form a huge cluster that can be able to do a lot of computational work. So with that, I'll be showing you the progress that we've made so far. And we also like have a pilot where we're trying to see how our fellow cousins in Africa can be able to join in that journey, and then we can be able to succeed together. So Martin, can I start? Okay, cool. As we wait for the presentation, anyone has a question or anyone want to ask anything before we proceed? Really, hakuna mtu amekuwa intrigued. No one has been intrigued by the conversation so far. You don't want to ask what DCP is or who we have reached to yet. I could be having swag, by the way. Oh, okay. There is a question.
Hi, not for the swag, by the way. I came in a bit late, but I think I might have stumbled upon what you're doing. My question is, how do you do the distribution in a way that it's either number one, efficient, or in a way, because the problem with these universities is, I would assume because you're engaging a lot of universities, each of them have different capacities in their ability to either have these computers online or have them in qualitative state in the way. So there's a base in which you need quality-wise to have these computers available. I don't know if I'm making sense. So how do you ensure that? Is that a layer that you'd have to deploy on top of like the compute, so that you provide on the other side, the people using your resources have some sort of an SLA?
I can jump in, Joseph, if you want.
So, and I think this is very cool that someone asked a question before I presented something that I'm going to present. So I feel like now I'm connected to the crowd and we can be able to begin. So this is the campaign. I don't know why I can't move So this is the banner that we are trying. So this is the banner that we are piloting. So Compute for Africa. So we have put our theme there, and and we are working with distributive, and I can see Dan is on the call. So ideally, we can, if you have any questions, we will have Dan later in the session, and we can be able to ask them. So Martin, let's leave. So we are working with a distributive that provides web native. So I want to really emphasize this, that it's web native. So anything that you can run on the web, we can be able to leverage that compute to be able to do all your AI work, your data cleaning, doing inferencing work using web native work. So if, for example, you're watching a video, you're using some level of GPU so that you can be able to see it in 4K. So imagine if you could be able to leverage that power that you're using for your compute, for your AI training. And we are trying to form a swarm of many computers that can be able to do AI training. And then if, for example, I'm a compute provider, I can be able to earn from that. And then we have like the DCP API. So the DCP API is the engine room of these pilot, where I'm able to deploy a job as a job provider. And then you, as a person who has computers, or in your laptop or in your phone, or even on your fridge, if your fridge can be able to access the internet, you can be able to earn credits by running my workload. So if I'm training a model, then I can be able to deploy some data, and then you can be able to work with, you can be able to earn from your idle compute. So what are the key components of DCP so far? So far, I've already mentioned that we have someone who is called a worker. So we have, so I'm not going to necessarily go in that order. I want to start with the basic person, the worker, the person who is actually doing the job. So in Kenyan terms, we call them KYM. So it's Kadayamo coined if you're from Mount Kenya. So the KYMs are the workers. So this is any computer, and there are different levels of workers. You can be able to deploy workers and say that they are dedicated workers called screensavers that you can be able to deploy on your computer. And then anytime that you're not using your computer, it will just like a switch, and it's available to execute work on the DCP network. And then, sorry, just remain on the same slide. So there is the compute API. So this is where an engineer in your organization who is working on your data can be able to deploy work within can be able to deploy work. So you are provided with an API key, and you can be able to deploy work. And then there is a scheduler. So this is the now within where the work is deployed. So if I have work, then it needs to be scheduled according to the capability of the computers that are available. And I liked his question because he asked how we're able to know the threshold. So the scheduler comes in handy to know that, for example, if I have 7 computers and one of them is very powerful, that computer is given more work than the less powerful one. So if you have a very powerful cluster, you get more compute credit because you're able to execute more work, since the scheduler can be able to detect the speed at which it sends you jobs and the speed at which you're able to return the results. And then the sweet thing, the compute economy. So right now, in the economy, we are having a way where, if, for example, I want to train an AI model, I take in my money. So I pay, like, let's say $10,000. I want to train my foundational model. So I put $10,000 and then put it on AWS. So the money comes from me to AWS. So in Kenya, I saw that I think last year we raised like around 83 million US dollars. And most of the startups are like tech startups, like AI training startups, and most of that money is going to be used in training, going to be used in buying compute resources. So, and that money is going to go back to Europe and US because they are the ones who have AWS. They are the ones who have like good data centers. And the compute economy that we're trying to create is, if, for example, we have a cluster, like we have a cluster at African Nazarene University. So part of that $10,000 that we're using, instead of paying it to AWS, it can be paid to African Nazarene University, so that the university has a different set of source of income by providing their already existing compute. And we also have another university or any other company that has idle computers. So if you have a lot of computers that are idle, you can be able to put them on the network, and then you can be able to earn from that. So yeah, so we can move on to the next slide. So And these are sample of workers that have already been deployed. So this is an example of a powerful worker. So this is in Dedan Kimathi University, where we have a computer with a gaming tower. So they have gaming towers within the university for researchers, and the professors there has created like that hub. But then like whenever the researcher who has been assigned that machine leaves the office, then that machine remains idle. But with DCP, it can be accessed by other researchers within the same institution or outside to be able to train their models. And you are going to like the professor will gain in terms of people are going to be able to do research, and then two, people are going to he is also going to earn some sort of return from his computer work. So this is an example in Africa Nazarene University. Okay, so I touched it and it's not supposed to be touched. Sorry. So, and we have another example. So this one is deployed in Canada. So this is courtesy of Dan. So the workers are run on the browser, and I hope like most of us are techies. How many non-techies do you have in the house? Non-techies. Victor, you are not a non-techie. Acha kuinua mkono. So if you're an non-techie, the browser, Chrome runs on JavaScript. So it runs, sorry? You're not agreeing with me. So Chrome runs on JavaScript. So it's called the JavaScript V8 engine. So anything currently DCP supports that JavaScript V8 engine. So if you can be able to make any language run on JavaScript V8, then we're good. So, and then like you can also use web GPU. So if you're training models on TensorFlow.js and then they have like their web GPU instance, you can be able to train models on that. And then the sort of workers that we have Docker workers. So I've seen the population of non-techies is very low. So I'm very sorry, but we have Docker workers. So a containerized way that you can be able to deploy your workers. You have a standalone worker. So this is where you deploy it on the computer. So for example, if I've deployed it on this, because this can also provide compute, it has a CPU in the background. If I've deployed a worker on it, then it's able to provide me with work. So anytime that I'm not using it, it goes into screensaver mode, and then it joins the cluster and can be able to do some work. So, and then we also have a web worker. So if anyone of you have your computer or even your phone, you can just go to dcp.cloud, and then you can just create an account, or for easier demo purposes, go to dcp.work/Qhala, and then I can give you the password, and then you can see how you can be able to contribute into the network. So the next thing is just the DCP API, and I'm really sorry to the non-techies for showing code, but then you have two options to deploy your jobs. You can use the JavaScript version, so you just use npm install. So in npm, there is already a package that allows you to format your code such that it works within the DCP API, and then there is also a Python package. So for data engineers in the house, I know you guys don't like JavaScript, don't like Java, you just like Python. So there is also a Python library for you guys. So next, so these are some of the supported libraries. So if you can train your model, you can either train it on JavaScript, and then actually there is TensorFlow.js, and then Microsoft has also been deploying some AI with JS, and they are currently running that. So if you can be able to run that, then you can also be able to run it on DCP. So please tell me when I start being too technical. I like being warned. So ukiona I'm being too technical, niambie kidogo turudie hapo. So now the most important part, the compute economy. So how do you make money, or how does the compute economy currently work at? So as I had explained earlier, in this economy, we are creating some sort of consortium. So I'm a company that has a lot of idle compute. So let's say like I'm a data, like there are some people who do like a BPO for AI data labeling. So they label data during the day and then they leave their computers there. So if you can be able to deploy screensaver workers on those computers, in the evening, all those computers will be used as nodes into the DCP cluster. So once they come in into the cluster, if I have a job and I want to train something, I'll deploy the job on the scheduler, and then they are going to take credits from my account. Like for example, if you look at my Joseph Qhala account, it has very few credits because I earned those credits by providing by doing computational work using my computer. But then if you look at my Qhala account, I'm very rich because Qhala is very wealthy. So in my Qhala accounts, these are accounts that you can be able to buy. So let's say I want to deploy jobs. So if I want to deploy jobs and I have a lot of money, let's say in my Qhala account, then I can be able to set that my API key is my Qhala account, and then I can be able to deploy jobs with that. So if you are the one who is going to do that job, you're going to receive the money. So the money comes from the one who is deploying the job, and then you can the one who is deploying the job to the one who is executing the job. So each and every time you deploy a slice of a job, you receive some compute credits. And yeah, so this is just an illustration of what I've just said. So if, for example, we have a computer vision application, so let's say we have a lot of cameras and we want to detect to know who has been driving in and out of Nairobi. So we take all those images and all those video recordings taken on the highway, and then we ideally deploy the job on AWS. So we have all that huge data set of images that have been recorded, let's say in a day, and then we deploy it on AWS. And then we pay AWS for them to process the images for us. But the new approach is, instead of paying that money to AWS, so we deploy the job on DCP, and then that money goes to, let's say, African Nazarene University, Dedan Kimathi, Qhala. All the money is distributed locally. So that is the whole proposition for compute economy. And the good thing with DCP is that we did a case study at African Nazarene University where we were running a use case. So we ran it on DCP and also on AWS. And the cost of running, if, for example, that job was being run like around every day, like on AWS, the estimation for 1 year was about like $1,000 and something. So with $1,000, you can be able to buy a very decent computer, right? And the job was run on DCP at $5. So at the end of the year, if you used like our native cloud providers, you won't have your money and you won't have your computer. But if you ideally like invested the money in a computer, then you can be able to run your jobs daily. So that is the value proposition that we have. And these are some of the current use cases that we do currently. So I know like most people, we've been having like most people want to fine tune LLMs and do inferencing with the LLM. We're not quite there yet, but we have some use cases that we can support. So if you want to train you want to use these models to train any sort of models and inferencing tasks. And finally the good part. So we are looking for, I don't know whether to call them, we are looking for more cousins to come into the pilot. So we are running a pilot, funded pilot, where we are looking whether you have a use case that we can be able to run on DCP. So we just get your current use cases that you have, and then we see whether we can run them on DCP. And then we are going to offset that cost. If you're already running it elsewhere, say you run your use case, let's say on Azure or on GCP, we are going to offset that cost for you. And then we run it on DCP for our pilot. Yeah, so with those many and few remarks, I guess that's the end of my presentation. MC, can I take questions now or later? So if you have questions, yes.
Hello, my name is Garoya Kamau. Quick one. Did you run any test on the power? As in, because your test was only deployed $5. Does that include even the power consumed?
At the moment, we haven't like started that consideration, but that's something that we're taking into consideration because some of the people that we reached out to ask us, how worth is it like for me to invest in like computers? So we also need to offset the cost of power and also the cost of internet. So that's something we don't have like clear statistical data to show that, like especially for Kenya. I'm not sure if there is data like for Canada. I'm sure ideally like maybe Dan's team has been able to do that for Canada, but for the Kenyan market, we haven't done that yet. Yeah.
Good morning. We do have that data. Can you hear me?
Oh yeah. So Dan, kindly chime in.
Yes, yes. Good morning, everyone. Very nice, and that was excellent, Joseph. Truly excellent delivery. My name's Dan. I'm a computational physicist. I use a lot of computing power for the research I do, and it's really fun to be building this concept of compute sharing, and not just within a single country, but can even be across the ocean. Not just to share computing power, but to share wisdom and collaborate and build projects together. The power consumption, let's put it this way, if the power consumption was too high, AWS wouldn't even exist. So the value of compute is much higher than the value of electricity, otherwise cloud wouldn't even exist. So a typical desktop or high power laptop normally consumes around 180 watts. That's its thermal design power at a maximum. And so if you take the cost of electricity for your local area and you multiply it by the power consumption, the thermal design power of that device, you'll get an approximate power consumption for that device for the year. And if, let's say you have a computer with 8 cores, 8 CPU cores and a GPU, if you add up the cost of renting those 8 cores and that GPU from the cloud for a year, you would probably be surprised, with the answer. I think most people here who've seen GPU prices, for example, are between $1 and $4 an hour if you get them on demand, and there are 8,760 hours in a year. So even at $1 per hour, we're talking about almost $10,000, which is wild when you think about it. And if you compare it, and that's just the GPU, the CPUs are 8 of them are worth quite a bit as well. In fact, it's between $200 to $400, depending on if you're getting spot or on demand. So if you have 8 cores times even the lowest price there, 200, that's $1,600 worth of CPU power for an 8-core computer. And so the question is the cost of electricity less than that? And a desktop is about $100 to $150 of electricity in Canada when we did our tests. So the cost or the value of compute is anywhere between 100 and 200 times more than the cost of electricity that went into making it. I hope that's helpful in terms of initial metrics, but it depends on the device and the location, the price of electricity, etc. Thank you for the question.
Thanks, Dan, for the breakdown. So Dan is very scientific and he's always pointing me towards facts, and sometimes okay. So thank you so much, Dan. So next question.
So I think my name is Alan. I'm a software developer. Okay. So I have a question. So let's say, for example, we've scanned that QR code. We are your prospective cousins. So for instance, I have a distributed question. It's a distributed systems question, for instance. So you're using the local network for compute. So understanding our local environment, we normally have internet disruptions, power disruptions. So let's say the system is working at capacity, and then one of the major cluster or a major node, let's say the Dunkin' instance, maybe you lose it online. So what happens to those to the jobs that were being processed at that instance? Will your customers lose the compute that they were processing at that time, or do you have what kind of fallback mechanism do you have in place in case you lose the major cluster?
So for that, whenever like so we call them nodes. So like let's say the example he's saying is like, for example, you have deployed a huge job, and several nodes are online, and one node comes out of the cluster, right? So we have fallbacks. So the scheduler is able to know that for this job slice has been deployed to a specific node and it has been completed. So if a job was deployed to a node and the node fell out, so the job won't be completed. So the scheduler will be able to reroute that job to another active node. So your job is going to take a bit longer since like you have lost resources. Yeah. Okay. So and the MC saying we only take like the final 2 questions.
Okay, Charles, my query is between running DCP on JavaScript as browser and Python, which one is more faster? And 2, when you're running maybe on a Python library, and do you need already to have subscribed to DCP, or what comes first? Is it subscription or learning the library?
I can
So
take this one.
yeah, let Dean take that one.
So your question on which one is faster, that's an excellent question. All of the execution happens in JavaScript, WebAssembly, or Web GPU. So even though you're writing or expressing your job through the Python API, it's actually still running in WebAssembly through a little bit of magic in the back end. I shouldn't say magic. And we've seen situations where pure Python, which is on average 43 times slower than C++ code, actually runs faster when it's executed in its WebAssembly form, because WebAssembly has a faster execution runtime than pure Python. However, most of the libraries that are leveraged by Python are C, and so performance will vary, but the overall speed up from distribution will dwarf any discrepancies at that level. Your other question was how to get started. If you're writing Python, it's pip install DCP. And then you need basically a certificate, or what we call a key store file on your computer, which you obtain from the portal. And that's basically all you need to go. And of course, if you're interested, we'll throw a whole bunch of examples your way, and we'll ask you about your use case, and we want to see this succeed. And so we want to work with people directly in these pilots and not just let them try and figure it on their own. The big caveat here is that we're looking for pilots that need the standard Python libraries. We're staying away from CUDA type training applications right now. We will get to that in the near future as we continue building out capabilities. So we're kind of going for the low-hanging fruit. So if you're interested and you're a developer, we want to speak with you and show this out and build more compute networks and connect institutions. And I believe there's someone from Safaricom in the audience. You have hundreds of thousands, if not more, chips throughout data centers all over the place. You can become a computational backbone for a country. It's impressive what compute can be leveraged from latent networks and put to good use, for driving local economies. So that was the request, was if you're a software developer, do get in touch. Let's build.
Thanks then for that. I think we're going to end the questions. Oh, you have one last one, really quick one.
So you have said that you have a scheduler that will distribute jobs based on the cluster that you have. So I was asking if you are having people who are providing the compute to your service, do you have a particular a standard way that you have agreed with the providers that during this time you will not be using your resources, so that we can be able to offload our workload to your to your node or your compute?
So for that, we have like it's called a screensaver. So each and every time, like let's say you're on your Windows computer. So anytime you're not using it, it usually sleeps. So instead of sleeping, it's going to display a screensaver, and then it's going to contact the scheduler, and it's going to tell the scheduler that I am online and I'm not being used currently. So you can send jobs to me, and I can be able to execute them. So that's how it works. So thank you so much, guys. I'll invite my MC back, and we can go to the next session. Thank you so much.
So thank you very much, Joseph. That's how you know he works on the back end most of the time. So we're going to have a short, let's say, a 15-minute break. You can have some tea. You can digest distributed compute, and then we can get back into the panel. I think that's okay. So 15 minutes only. So we get back, let's say, at 11:25. We're back here. And just the coffee and the snacks are right back, just right behind you. We can have that for 15 minutes, and then we get to the panel. Everybody is okay with that? Cool. Okay. Also, the people who are online, we have a 15-minute break, then we start again.
And there is very difficult to just simulate conventional because we have a lot of references from testing, real-time testing in the wind tunnel. So we really have developed then a digital twin of exactly our wind tunnel where you then can simulate with and really compare with the real testing in the
coffee and you're ready for more engaging conversations from the panel. We start in the next 2 minutes. So I'd like us to all take our seats and get ready. I will ask the panelists to please come up and take your seats. The panelists who are here. So I can see Dr. Betsy is there. And so how we'll do the panel is we'll spend the first 20 minutes, just hearing from the panelists, and then we'll spend the next 10 minutes taking some questions from the audience. So it's going to be a free flowing conversation. It's not one of those very rigid ones, right? Because we have practitioners, people who've been doing this for a while. So Dr. Betsy, please have a seat, and then I will ask for Dr. Tim as well. Dr. Tim Kamano. And then Mr. Joseph Miner, we'll ask you to come back up. And then I believe we have Engineer Andrew Masila online, if he's online, or... Okay, you're all very lucky to have these minds together on the panel. So I think we have a lot of institutional knowledge about machine learning and AI in practice, in academia, on the panel here today. Whether you're on the back end things, running models, or doing research and deploying actually use cases in the field, or you're also in the university. So is Engineer Andrew on? No. Okay, no problem. He will join us when he comes online. Okay. So as we get started, thank you very much to the panel for making time to be here with us. I can get some mics. Okay, thank you. Okay, so our panel today is going to be around the conversation around compute and AI sovereignty. So we're going to traverse the different facets of what it means. And please, I'll ask the people who are online, please put yourselves on mute for now. So we're going to traverse the landscape, or in the context of today's watch party, around what's happening at the NVIDIA GTC, at VivaTech, and how the CEO, Mr. Jensen, is actually going to be having a conversation of how we can actually have compute distributed globally and democratizing this. We started earlier with a conversation from distributed compute, DCP, and how they're trying to also democratize access to compute through using the idle that is actually available in a lot of institutions. Right, so our panel today is a very distinguished panel. We have Dr. Betsy Muredi, who's a research fellow at iLab Africa at Strathmore University. She's also a practitioner. She's actually deployed solutions in the field in low compute scenarios. We also have Joseph Miner, who's a backend engineer at Qhala. And then we also have Dr. Tim Kamanu from the University of Nairobi, data science department. And so we're going to have a conversation around compute today. And I will now allow, starting with Dr. Betsy, a bit of an introduction and give us a bit of a landscape and anchor us on, your space within compute.
Thank you, and thank you for the invite. So I work at iLab Africa. iLab Africa is a research center looking at developing ICT solutions for sustainable development. We have multiple units. I specifically work with the data science unit. So our job is looking at how can we democratize data for decision making, whether it is a manager at an organization wanting to accelerate his data-driven decision making, or a local farmer who wants actionable weather information. So we do a lot of projects across that that domain, that cross-cutting domain on democratizing data for decision making. We do a lot of training, and we do also a lot of consulting around data strategy, data audits, and all that. So in terms of compute, I think when we started off the unit, we didn't have a lot of compute resources other than gaming laptops, right? And so our first projects were looking at training machine learning models for natural language processing for Swahili voice, text-to-speech analysis, STT as well. And then over time, we've kind of realized, okay, we used to have access to AWS credits. So there's different AWS for academic credits available. But then you realize that, fine, you can get the credits, but access to GPUs themselves is quite limited. Either there's a long queue or it's just not available for even if you pay, you have to still queue to access GPU. So we went ahead and got, the gaming tower. So we have an RTX 4080 and we're getting an 5070. But again, I guess that's enough for now for our computing needs because it's still at training models. We haven't even thought about what that would look like when we start doing inference. And so that will likely to grow. And then within the wider ecosystem of academia, we have KenNet. KenNet is the NREN for Kenyan universities, and they have a GPU cluster. So they have about 8 NVIDIA A30 GPUs, GPU cards to be shared across how many universities do we have in Kenya? And so they can currently support 7 researchers a month. And these researchers are not just machine learning researchers, they're your physicists who are doing computational physics. You have your people who are doing weather or bioinformatics. And so that capacity for a whole country is quite limited, but they are growing. So we are not starting from zero, we are starting from somewhere. And then as a last result, we have the AWS and the cloud compute. Only because you need a budget line. So I can't go to my head of department to say, I want to do a proof of concept for XYZ, give me money to buy AWS credits. So you need to, think of a proposal, find funding, and by the time you find funding, you get accepted. That whole cycle, it might be 2 years, 3 years down the line. And so I guess that's the conversation, and I really like the DCP idea because sometimes you want to do random research things. You have an idea in your head, you want to test it out. It's not fundable because maybe it's not exciting currently. Right now, the big buzz is LLMs. So if you're not doing anything within LLMs, finding funding for your interesting idea might be difficult. Or if you want to go beyond LLMs and identify new frontier AI spaces within the African content that require compute, you might be pressed. So I do really like the DCP idea. And I hope you get more universities to join. I didn't know DECUT had a whole lab of workstations, of towers. I think I need to go back to our admin and our IT information IT department to really give them a awards because we are lagging behind at Strathmore. So yeah.
Okay.
I mean, no, I want mine because if I use theirs, I need money. So I want something. I wake up in the morning, I have this idea. I wash a computer somewhere. I build my model without now having to either dip in my pocket or ask the head of department to give me money. So I think, yes, it's good. That's a starting point to keep that compute within ourselves. But I do think universities need to make that investment for their researchers if you want to advance in the research space. Yeah.
Okay, thank you, Dr. Betsy. So now we're going to bring in engineer Andrew Masila from Safaricom. who's the head of research, is a lead for research and innovation at Safaricom. Well, the largest tech company in the whole of the Eastern Central Africa region. And so he's, literally in the practice, right? He's using GPUs, give access. This is an industry perspective. So please, Andrew, Engineer Andrew, the floor is yours for an introduction. And we get
Okay. So can you hear me?
Yes, loud and clear.
Okay, so good morning. Excited to be here. I think this is a topical discussion. I think Mtembe has done justice in terms of the introduction. For me, I'm excited to be in this conversation and really to pick from the work we did within the National AI Strategy. And within the National AI Strategy, it's sort of, we are looking at, do we put the solution before the problem, which means, do you flood the market with your computes and then you start looking for use cases? Well, there are elements for that because we really need to experiment. But critically, when I look at, what AI means in Africa, more of it is towards the edge. When you look at it from a positioning perspective. And that said, I think the key principle that I'll be contributing to in this discussion is to see how we can actually build AI at the edge. There's distributed computing, but also there's an element of going beyond what is already existing and seeing how we can actually package the existing resources for the same. That said, I'll be sharing a few initiatives which we have already done and some of the things we've done for our staff, and maybe a suggestion to see other institutions, how we can actually collaborate and partner. But thanks for having me on this call. Thank you.
Thank you, Engineer Andrew. That's a great perspective from the industry enterprise side of things. And so moving on to Dr. Tim, give us an introduction and also based on your experience at UN and in the academia space.
Yeah, thank you, Mutembe. My name is Tim Kamano. I head the data science division at the Department of Mathematics. I must also mention that I'm AU trained. I'm trained by the African Union through a network called the African Institute of Mathematical Sciences. And the goal was to capacity builders and then come back to Africa and do possibly what we are talented in and scale it across the continent. So before I talk about compute, I should tell you a bit about a small story. This is quite interesting, actually following up from conversation about Africa AI strategy that we started in Kigali at the Global AI Summit. So when we got to a PhD, like around 14 years ago or 13 years ago, so I came back from the Middle East, where we were actually endowed with around $20 billion of university and compute power. So we are computing on the fourth fastest supercomputer in the world. And you are edgy, you are techie, and you come back to Africa to say, okay, I'm going to run the same here, only to realize that you have no compute. And actually, if you have compute, then you're the only one to be computing in it. So most of the time will be idle time. And that's why the conversation today is actually quite interesting. So I'm a bioinformatician, but I apply maths and stats to determining cancer-causing genes with quite high accuracy somehow. And I believe we can lead in some of these fronts, especially in the AI front. So the compute is highly tied with capacity training, talent development. So we can't actually utilize efficiently compute power without enabling talent. And that's why in my second hat, said I am at the Department of Mathematics. So the other hat that I got was to establish a lab. We call it the Data Analytics and Scientific Computing Lab, where we train mathematics, but program it. Yeah, so I also founded Dask Lab just to enable talent development within that, so that we move from textbook examples to actual real life data crunching. The third hat that I wear is I also am a copy at Engage. Engage is an acronym that stands for Enabling Girls in AI and driving expertise in data science. So we are seeking to train 1,000 data scientists in Kenya across the country, and capacity build them to actually develop solutions where they are. So we are not training at the University of Nairobi. We are training with alongside 6 very able partners, including Dekut, Kabarak, Pwani University, and Seku, as well as Jaramogi Oginga Odinga University, just to represent the entire map of Africa, of Kenya. The reason being, we need to also shift the, the AI frame and the compute environment in Kenya is shaping up. So as we shape it, there is a tendency of translocating the problem solvers. So we move someone from Kisumu to Nairobi, most likely they'll never go back again there once they are techie as the people in this room. But then you move them away from the problem which they really have grown up with. And I think that's where we actually have the best scenario to actually develop very practical use cases to subscribe now the same to a compute environment, which now we are deliberating today. Thank you.
Thank you very much, Dr. Ari. So now to the backend engineer. So to Joseph, please, give us also a practitioner's, background in the challenge of compute, and also, frame for us where compute lies in your perspective.
So thank you, and thanks for having me once again. And it's the computer ecosystem in Africa is a bit like I've been trying to do like a bit of reconnaissance. Like we try and go to researchers, and you go to a startup, and you tell them. So there is like, let me just first put it in 2 phases. One, the DCP phase. We're trying to get people who have compute. So, and if you ask people to provide you with compute, they give you a lot of, everyone has a computer, everyone has a laptop, everyone, there are countless data centers, like within Nairobi. There is Konza, there is another one, I guess, in Tatu City, we have KNet, there are all those, and others, like even international ones. We got people who from Australia who were willing to provide compute for Africa. And I'm very lucky to be on the panel with people who have gone like through that journey. And one of the things that we noticed that was a bit lacking is use cases. So in my small business like experience, so we have supply versus demand. So we have like a lot of resources that are not being actually used. Like you'll find there is a lot of compute. We have like good compute capacity that can be used. But then if you ask people, like for example, for DCP, for the use cases that are there, not many people show up if you now ask people to solve problems. So I think the conversation should be what African problems are we trying to solve? So in a business, what do we actually target so that our business makes sense? So let's say an industry that is making a profitable industry in Africa, let's say finance. So we have Safaricom, we have Flutterwave in Africa. So how can we plug into that industry and solve a problem that is affecting that industry? in healthcare, in agriculture, so that we can have Africans say, even our government say, for example, in our agriculture budget or in our education budget, yeah, we have like I think half of it, the Giant Alliance share for this year's budget for Kenya is going to education. How can we plug into that money that is being used by the government to fund education that can be used to power compute? So ideally, we need to identify a problem in education that can be sorted by computer, and then we can be able to afford that compute. And yeah, ideally, we also need compute for researchers, as my fellow panelists have said. I remember when I was doing some research and I wanted to like access to a GPU, and I had the money to pay Google Cloud, but then I went to Google Cloud and then input my Kenyan card, and it was declined. I couldn't be able to pay from Africa. So availability of compute also sometimes limits innovation. So we had to look for researchers in the US so that they could be able to give us those resources. But the idea was ours. But then now we have to involve a third party. So you have the brains, but you don't have the power to do it. So bringing in compute capacity, and that's why we're here, to build an ecosystem for Africans where all those resources are available at their fingertips, so that you can be able to innovate on it.
Thank you very much, Joseph. So now I'll go back to Engineer Andrew and just ask, share with us, what lessons has Safaricom learned in optimizing computers at scale, because you're operating on a huge scale, and what advice would you give others?
Okay, please confirm whether you can see me, right?
Yes.
All right, so I think from the lessons we have picked, and it's been an amazing journey, so it's sort of a split, and we've done benchmarking across what other tech companies are doing, and we settled on a scientific approach. And the scientific approach, it's sort of your chicken and an egg scenario. And the reason I say this is because, yes, you do need compute to scale some of the use cases, but also there's the initial phase of proof of value. So we took an informed risk approach where we did set up a lab. And the premise for setting up this lab was to take a level which you can risk, a good enough level of risk. And from what we've seen, it's sort of your 80-20 rule, where we say if the investment is X amount, at least 20% should be for research. I know it's an approach that is quite transformative, and we've picked a number of lessons. And when we acquired NVIDIA, their H100 GPUs, at that moment, and I think each is about 80 GB. At that moment, it was a race of which parameter has, the most number of parameters from 7B. I think when we acquired them, when there was actually a chip shortage, we are seeing the 400 billion parameters were starting to come out. So using this risk-based approach, we're able to train models up to 7 billion parameters with that infra. But the key question that now we asked ourselves is really, how do you continue scaling with this space? And logically, looking at Africa, then it's the edge is where it actually makes sense. So in terms of the experimentation, also trying to do more things within the edge space, and that is coming about, but also trying to leverage on use cases. So I know skills has been talked about. So something else that has helped that journey across the entire organization, we've skilled everyone with at least AI introductory skills across the organization, so that everyone is AI fluent, if I can call it that way. So using that, then you're able to have resources across the organization take advantage of the current capability that is there. Then in terms of now looking to scale that to business needs, then that takes an approach where we are looking at the use cases. And at Safaricom, our key approach is to see how can we deploy technology in the best way to actually service our customers. So that has been the learning and the approach. And actually now also going back to how the national AI strategy was done, it gave a very good framework, and hopefully it's implemented. But I think for me, the key charge is, as we are here, and I know there's also big tech companies here, is to say, besides waiting for the national implementation, the document is actually quite a sound document, which an institution like a university or even a startup or a company operating in Africa can actually take advantage. So it's interesting because the approach we've actually built with is the same approach that we see within the national strategy. So in summary is to say a sort of an appreciable level of risk that is controlled within a lab environment. I think that would be very sound. And then as we come to make investments, of course, it would be good if we have national priorities, but nothing stops us from having a meeting of minds so that we can really craft the use cases so that when we are doing a sort of our business cases and models for AI, then we have sort of 1 or 2 or 3 use cases that we can rally together as an AI community to execute. Thanks.
Thank you. Thank you very much, Engineer. Now I will go to Betsy. And so what are the critical skills gap that you see are needed to fill so that we can actually be able to, really take advantage of compute and even to solve the challenges of the scarcity in compute?
Yeah, I won't call it a skills gap, but rather a reframing of how we teach or the current courses. So like Dr. Ritima said, moving away from the textbook into more practical solutions. So in computer science, you have your usual database management, networking, moving towards now things around data engineering, which we've seen it's a huge gap even for basic business intelligence. Creating the pipelines needed for your organization to aggregate its siloed data sets, efficiently manage that database, requires a move from the usual SQL teaching that we are used to more data engineering, NoSQL, Hadoop, BigQuery computing and all that. We also need more machine learning AI engineers that are able to, beyond just training, are we able to deploy? Are we able to maintain those models? There's a lot of system dynamics, optimization parameters that mathematicians learn from a textbook perspective, but are yet to apply towards the things to do with maintaining machine learning and AI pipelines. Responsible AI, AI safety and governance. There's a lot of system dynamic modeling that needs to be done to analyze catastrophic events. So if an LLM was to, refuse to be shut down and have sentient or autonomy, what does that mean for Kenya, for example? So there's a lot of research, a lot of areas that we probably just need to shift what is currently offered to be more forward-looking and digital skills for the future, including basic AI literacy for our students. How do you use, LLMs are being used, so how do you use it responsibly for you to augment your skills rather than dim them? So yeah, I think I'll add that, and I'm sure Dr. Ari has more to add. So I'll also throw him the question.
Okay, thank you very much. So I'll quickly jump to bring in Mr. Lucas Omolo, who's the Chief Manager, ICT and Smart City Solutions at Konza, just to also introduce himself and also answer a question around what is Konza Technopolis doing to build a robust, future-proof computing for smart cities. Mr. Lucas, are you on?
Yes, thank you. Thank you so very much. Confirm you can hear me.
Yes, we can hear.
I can hear you.
Lucas, we can hear you. Please continue. You can tell us what Konza Technopolis is doing to build a robust, future-proof compute infrastructure for smart cities.
Great, thank you. Thank you so very much. And sorry, I really wanted to be with you guys. I was actually on my way when I got another urgent assignment that I could not escape. So at Konza, and thank you, Qhala, for organizing this. At Konza, one of the things we are driving is a digitally empowered economy. And if you look at the pillars that necessitate that, I think you've mentioned, is a processing infrastructure, which is a data center. Then, of course, you need data. That now is a key ingredient in any economy that is aspiring to be successful. Then the other pillar now becomes skills. So you've also seen a lot of initiatives that we facilitate or run around skilling from both tech perspective, greenfield skills on AI, cloud computing, IoT, and many others. Then the last aspect becomes regulations and policies, which through the support of our ministry, we are getting that support to review and even enhance the capability of our policies. But now back to your question on what we are doing as cons. I think being a smart city, a robust cloud infrastructure becomes very important for us to then support this country digitally, and this is because all these data that we collect must be harnessed and processed somewhere. And what we've done is we've established a Tier 3 national data center that today supports close to 200 entities spread across private sector as well as government. But the most important thing to mention for this particular audience is that Konza has also opened that cloud infrastructure to support local innovation. We provide free hosting for at least a year for those who are doing pilot projects across emerging tech areas. It could be IoT, it could be cloud, and these could be solutions that are targeting specific sectors of the economy, from agriculture, education, health, tourism, and many others. So we give you an opportunity to showcase, and we've gone further to establish an experience center through which you are able now to demonstrate and showcase this to the rest of the country and the rest of the world.
Okay, thank you, Lucas. I think we'll have to slow down because time is catching up with us. We're just about to start with the watch party. So thanks so much, Lucas, for that. And I think now we all know that we can actually use the cloud locally in Kenya, from Konza Technopolis to actually run our models. So now, because the Zoom is going to close in about 2 minutes. What we're going to do is I'm just going to ask the panel, I'm just finishing up from Dr. Tim, to just give us, 30-second closing sort of remarks around, what do you think the future of getting access to compute and AI looks like in Kenya from your perspective. So 30 seconds from Dr. Tim, and then we'll come to you, Joseph, and then again to Dr. Betsy and Andrew.
Yeah, what's the future for AI? It's very bright, but we have to face some challenges upfront. Biggest challenge, I think, is a silo mentality that we are set up. We need to adopt a more focused problem-solving approach. And I know no problem that requires only a computer scientist. Without the need of a medical specialist. So if we focused on multidisciplinarity, collaboration, and if we think about also the 3 axes that actually support AI, data, talent, and compute, then we're going to get it right.
Thank you very much. 30 seconds from Engineer Andrew.
Okay, so for me, the future of AI is actually the edge in Africa, but also looking at the youth dividend and also the digital promise, and also coming back Kenya, the active Kenyan voice over the internet. So for me, those are all bells and whistles. We just need to assemble the car so that it drives us into the future. Looking forward to that.
Thank you, Andrew. Quickly, Dr. Betsy.
I guess the future for AI is, from my perspective, enabling research. We've been talking about how we need, to build for Africa, for Africans, also fund AI for Africa by Africans. So maybe a quick poll, how many people donate to their endowment fund from their alumni? Right? A lot of the universities in US, we are seeing Trump is pulling out funding, and they're able to run because of their endowment funds. Endowment funds are from alumni. So if we can do basic, simple things like, fund our universities, fine. The government has its own priorities right now, so I won't go into that. But us as, alumni, what are we doing to support research in Africa if you want to build models for Africa by Africans? Yeah.
Thank you. Joseph.
So I'm very, very excited about the future of AI, especially now that we are in the phase of agentic AI, and it's going to be a place where we have to leave tasks to AI. So we also need a lot of talent. Talent needs to shift so that it can be able to handle those agents. So we also need to prepare the African talent to handle the agentic future that is coming from AI.
Thank you, Joseph. And lastly, but not least, Lucas, 30 seconds on what you see the future of AI and compute.
For me, I think the future looks bright, but only if upon, of course, I like the aspect of talent, that we are able to localize AI to basically speak to us. If it is a language model, let it speak to us. Let us now. I know you've seen the level at which we, for example, adopted ChatGPT, but are we really saying that it's speaking to our Wanjiku? So for me, a challenge to all of us, that let's see how we take advantage of fourth industrial and partnership, collaborate, then localize this to speak to our requirements and perspectives as Africans. Thank you.
Thank you, Lucas. So localize, fund research, collaborate, put money into your endowments in your local alma maters. The triple helix, we really need to combine academia, industry, and business. Academia, industry, and government. Yeah, we need to figure out to combine that. Agentic AI, how do we do that? And edge AI from Andrew. So thank you very much. I think we won't have that much time for question and answers, but the panel that's here is around. You can have conversations with them. And I think we are quickly going to switch to the watch party. And I think the next is the head of NVIDIA for the African ecosystem, Fatima, is going to be speaking. I believe that's the next one. Thank you very much.
Awesome.
Another clap for our panel. They did a lot. They should be paid for the amount of content they have given us. Thank you.
Just wanted to make sure everyone can hear me.
Yes, Fatima, we can hear you.
Perfect. Good morning, good afternoon. Thank you guys so much for having us today. Really wish I was in the room with all of my fellow cousins. But super, super excited to hear about the conversation that's been going on. I think the panel did a really, really good job talking about the role of universities, research, and I liked the point on reframing talent. Specifically around how can we bring in more practical elements. And we actually have an offer with regards to that. But happy to do a quick intro, and then we can get into the watch party. So as you may know, my name is Fatima Tambajang, and I lead our developer relations for Africa and the Middle East. So essentially, we work with different developers, startups, enterprise, and universities. Success for us looks like helping you guys create use cases. And that was another point that was brought up in the panel. So today we'll be going into the watch party, which is being streamed live from Paris. Feel free to join online so that you can chat with us via the Google link chat, and then we can answer any questions. And if one has questions, feedbacks, or insights, feel free to share them in the chat live as we go. And then towards the end as well, we can do a quick check-in. So I'll just share my screen quickly to do a quick overview of what you can expect, share some of the developer resources that we have, and then share a QR code with one of the courses that we're offering completely for free today as a result of our partnership with Qhala, which we truly, truly appreciate. And again, all of these resources will be shared with the Qhala team so they can get it to you as well so that you can reference it later on. Can everybody see my screen?
Yes.
Perfect.
Please welcome Jensen Huang.
AI is able to solve more interesting problems for more industries and more companies.
The purpose of GTC is to inspire the world on the art of the possible of accelerated computing.
I love what we do. I love even more what you do with it.
Wonderful. So I hope everyone is super excited about today's GTC. I hope everyone was able to hear the sound. Hello?
Yes, we were able to hear the sound.
Perfect. So as I mentioned, we work with developers, the team that I sit in. And what does that look like? That looks like 4 key resources that we have for different developers. Some of you are already aware of it. The Great MC, for example, is part of our Inception program. And our Inception program focuses on working with startups by providing startups with access to cloud compute. We provide startups to access to go-to-market support, and then also technical enablement. We also have something called our developer programs. And within our developer programs, you have access to hundreds of SDKs, libraries, and product releases to essentially help you accelerate the work that you're doing, lower your compute cost, and then also make your workload and development cycle a lot more efficient. And then we have our training program. So our training program is a combination of self-paced courses and also courses with instructors. Our training programs typically cost anywhere between $90 up to $500. But as I mentioned, as a result of our partnership with Qhala, today we're offering one of our self-paced courses that are paid for completely for free. And then the other thing that we also have is our Inception VC Alliance. So after we enable startups and after they ship their products, we're able to put them in touch with different VCs that are looking to make investment into solutions. So here we have our self-paced course. As I mentioned today, this is completely complimentary due to our partnerships with Qhala regarding this watch party and the fantastic CTO breakfast meeting. I'll leave this on the screen for a few seconds so that you can scan the QR code, which will take you straight to this course. You will have about 6 to 10 courses that you can choose from, and those courses range from accelerated data science. There's a lot on edge computing. There's also courses on Jetson. There's also courses on CUDA and the fundamentals of deep learning. But again, as I mentioned, all of these slides and information will be shared with the Qhala team so that you can reference them later. And now we'll go into the watch party. So we'll just stream it live and we'll be online. If anyone has questions, comments, feedback, feel free to share them in the Google link chat. And then we'll just chat along. And then at the end of the watch party, we can spend a few minutes and talk about what were the key insights, what were you super excited about, and what would you love to learn more about, so that for our next engagement with Qhala and its ecosystem, we know how to add additional value. So this is it for now. Let's head over to the watch party and looking forward to all of the insights. Karibu. Awesome. So I believe the Qhala team will start the streaming on their side as well, and then we can commence that. Please let me know, Qhala team, if that's the plan.
Fatima, could you please bring up the QR code again? I think people didn't see it.
Sure.
let's just, so just for people, real quick before we start. Could you share it on full? Okay, perfect, thank you. Is everyone good? So just a few more seconds before we start.
No worries at all. GTC just started a few minutes ago. So as I mentioned as well, I'm happy to share this in the chat for further reference.
Okay, everyone, good. Thank you very much, Fatima. And as she said, NVIDIA has an amazing NVIDIA Inception program for any of the startups here that are interested in building with some of the best technology out there. Thank you.
Awesome. So just wanted to make sure that on your side, you're able to access the live stream.
Yes, Fatima, we actually do have the live stream live
Perfect.
right now.
All right, perfect. So I'll be in the chat if anyone has questions, comments, and then I will see you guys soon. I will turn off my camera and
Thank you, Fatima. You're on mute now. Thanks.
Computing companies all over the world in several different ways. But here in Europe, there's a large community. I saw Pascal last night. I saw computational lithography, direct sparse, some interesting problems in the coming years. This is a really exciting time. And so we've been working with all of the supercomputing centers. It's very clear now that over the next several years, or at least the next generation of supercomputers, every single one of them will have a QPU assigned and QPU connected to GPUs. The QPU will do quantum computing, of course, and the GPUs would be used for pre-processing, for control, for error correction, which will be intensely computationally intensive, post-processing and such. Between the two architectures, just as we accelerated the CPU, now there's QPU working with the GPU to enable the next generation of computing. Well, today we're announcing that our entire quantum algorithm stack is now accelerated on Grace Blackwell 200, and the speed up is utterly incredible. We work with the quantum computing industry in several different ways. One way is using cuQuantum to simulate the qubits or simulate the algorithms that runs on top of these quantum computers, essentially using a classical computer to simulate or emulate a quantum computer. At the other extreme, extremely important is CUDA-Q, basically inventing a new CUDA that extends CUDA into quantum classical, so that applications that are developed on CUDA-Q can run before the quantum computer arrives in an emulated way, or after the quantum computer arrives in a collaborative way, a quantum classical accelerated computing approach. And so today we're announcing CUDA-Q is available for Grace Blackwell. The ecosystem here is incredibly rich. And of course, Europe is deep with science and deep with supercomputing expertise and deep with heritage in this area, and it's not surprising to see quantum computing advance here. In the next several years, we're going to see a really fantastic inflection point. So anyways, for all of the quantum computer industry that have been working on this for 3 decades now, I congratulate you for just the incredible accomplishment and the milestones today. Thank you. Let's talk about AI. You might be surprised that I would be talking to you about AI. The same GPU that ran and enabled all of these applications that I mentioned, that same GPU enabled artificial intelligence to come to the world. Our first contact was in 2012, just prior to that, working with developers on a new type of algorithm called deep learning. It enabled the AlexNet big bang of AI, 2012. In the last 15 years or so, AI has progressed incredibly fast. The first wave of AI was perception, for computers to recognize information, understand it. The second wave, which most of us were talking about the last 5 years or so, was generative AI. It's multimodal, meaning that an AI was able to learn both images and language. Therefore, you could prompt it with language and it could generate images. The ability for AI to be multimodal, as well as able to translate and generate content, enabled generative AI revolution. Generative AI, the ability to generate content, is fundamentally vital for us to be productive. Well, we are starting a new wave of AI. In this last couple of years, we've seen enormous progress in AI's ability. Fundamentally, intelligence is about understanding, perception, reasoning, planning a task, how to solve a problem, and then executing the task. Perception, reasoning, planning, the fundamental cycles of intelligence. It allows us to apply some previously learned rules to solve problems we've never seen before. That's why intelligent people are considered intelligent. To be able to take a complicated problem, break it down step by step, reason about how to solve the problem, maybe do research, maybe go learn some new information, get some help, use tools, and solve problems step by step. Well, the words that I just described are fundamentally possible today with what is called agentic AI, and I'll show you more in just a second. In the physical implementation of that, the embodiment of that agentic AI, and the motion, now the generative capability is generating motion. Instead of generating videos and generating images or generating text, this AI generates locomotion, the ability to walk or reach out and grab something, use tools. The ability for AI to be embodied in a physical form is basically robotics. These capabilities, the fundamental technology to enable agents, which are basically information robots, and embodied AI, physical robots, these two fundamental capabilities are now upon us. Really, really exciting times for AI. But it all started with GeForce. And GeForce brought computer graphics. This is the first accelerated computing application we had ever worked on. And it's incredible how far computer graphics has come. GeForce brought CUDA to the world, which enabled machine learning researchers and AI researchers to advance deep learning. Then deep learning revolutionized computer graphics and made it possible for us to bring computer graphics to a whole new level. Everything I'm going to show you today, I'm going to give you a preview of what I'm going to show you, but everything I'm going to show you today is computer simulation, not animation. It's photon simulation, physics simulation, particle simulations. Everything is fundamentally simulation, not animation, not art. It just looks incredibly beautiful because it turns out the world is beautiful, and it turns out math is beautiful. So let's take a look. What do you think? Numbers in action, numbers in action. That's essentially what simulations are. And it's just incredibly beautiful to look at. But because of the scale and the speed by which we can now simulate almost everything, we can turn everything into a digital twin. And because everything can be a digital twin, it can be designed, planned, optimized, and operated completely digitally before we put it into the physical world. The idea that we would build everything in software is now upon us. Everything physical will be built digitally. Everything that's built magnificently will be built digitally. Everything that's operated at gigantic scale will be first built digitally, and there will be digital twins that operate it. And so today we're going to talk a lot about digital twins. Well, what started out as a GeForce graphics card, anybody in here know what a GeForce is? Okay, all right. Well, what started out as GeForce looks like this now. This is the new GeForce. It is 2 tons, 2.5 tons, 1.2 million parts, about $3 million, 120 kilowatts, manufactured in 150 factories, 200 technology partners working with us to do this. Probably something along the lines of $40 billion in R&D budget in order to create what is GB200, and now moving to GB300, it is completely in production. And the machine was designed to be a thinking machine. A thinking machine in the sense that it reasons, it plans, it spends a lot of time talking to itself, just like you do. We spend most of our time generating words for our own mind, generating images for our own mind before we produce it. And so the thinking machine is really architecturally what Grace Blackwell was designed to do. It was designed to be one giant GPU. I compared it to GeForce for a good reason. GeForce is one GPU. So is GB200. It is one giant virtual GPU. Now we had to disaggregate it into a whole bunch of components, create a bunch of new networking technology and SerDes technology, incredibly low power, high energy efficiency interconnects to connect all of these chips and systems together into one virtual GPU. This is the Hopper version. This is the world famous Hopper system. This 8 GPUs connected together on NVLink. What's not shown here is a CPU tray. A CPU tray with dual CPU and system memory that sits on top. Together, this represents one node of an AI supercomputer. About $500,000. This is the Hopper system. This is the system that really put us on the face of the map of AI, and it was under allocation for a very long time because the market took off so quickly. But this is the famous Hopper system. Well, this entire system, including the CPU, is replaced by this Grace Blackwell node. This is one compute tray. Right here will replace that entire system. It is fully liquid cooled, and the CPUs are integrated directly connected to the GPUs. So you could see it here, 2 CPUs, 4 GPUs is more performant than that entire system. But what's amazing is this. We wanted to connect a whole bunch of these systems together. How would you connect all of these together was really hard for us to imagine. So we disaggregated it. What we did was we took that entire motherboard, we disaggregated into this and this. This is the revolutionary NVLink system. Scaling out computing is not that hard. Just connect more CPUs with Ethernet. Scaling out is not hard. Scaling up is incredibly hard. You can only build as large of a computer as you can build. The amount of technology and electronics that you could fit into one memory model is incredibly hard to do. And so what we decided to do was we create a new interconnect called NVLink. NVLink is a memory semantics interconnect. It's a compute fabric, not a network. It directly connects to the CPUs of all of these different NVLink systems, compute nodes. This is the switch. 9 of these stands on top. 9 of it sits on the bottom. In the middle are the NVLink switches. And what connects it together is this miracle. This is the NVLink spine. This is 100% copper. Copper coax. It directly connects all of the NVLink chips to all of the GPUs, directly connected over this entire spine, so that every single 144 Blackwell dies, or in 72 different packages, are talking to each other at the same time without blocking, all across this NVLink spine. The bandwidth of this is about 130 terabytes per second. 132, I know. No, wait for it, 130 terabytes per second. If it's in bits, 130 terabytes per second, it is more than the data rate of the peak traffic of the world's entire internet traffic on this backplane. And yeah. So this is how you shrink the internet into 60 pounds. NVLink. And so we did all that because the way a computer is considered, the way you think about computers is going to be fundamentally different in the future, and I'll spend more time on this, but it was designed to give Blackwell a giant leap above Hopper. Remember, Moore's law, semiconductor physics, is only giving you about 2 times more performance every 3 to 5 years. How could we achieve 30, 40 times more performance in just 1 generation? And we need a 30, 40 times more performance because the reasoning models are talking to themselves. Instead of one-shot ChatGPT, it's now a reasoning model, and it generates a ton more tokens when you're thinking to yourself. You're breaking the problem down step by step, you're reasoning, you're trying a whole bunch of different paths, maybe it's chain of thoughts, maybe it's tree of thoughts, best of n. It's reflecting on its own answers. You've probably seen these research models reflecting on the answers, saying, is this a good answer? Can you do better than that? And they, oh yeah, I can do better than that, goes back and thinks some more. And so those thinking models, reasoning models, achieved incredible performance, but it requires a lot more computational capability. And what netted result, NVLink 72, Blackwell's architecture, resulted in a giant leap in performance. The way to read this is the x-axis is how fast it's thinking. The y-axis is how much the factory can output supporting a whole bunch of users at one time. And so you want the throughput of the factory to be as high as possible, so you could support as many people as possible, so that the revenues of your factory is as high as possible. You want this axis to be as large as possible because the AI is smarter here than it is here. The faster it can think, the more it can think before it answers your answer. And so this has to do with the ASP of the average selling price of the tokens, and this has to do with the throughput of the factories. These two combined in that corner is the revenues of the factory. This factory, based on Blackwell, can generate a ton more revenues as a result of the architecture. It is such an incredible thing what we built. We made a movie for you just to give you a sense of the enormity of the engineering that went into building Grace Blackwell. Take a look.
Blackwell is an engineering marvel. It begins as a blank silicon wafer. Hundreds of chip processing and ultraviolet lithography steps build up each of the 200 billion transistors, layer by layer on a 12-inch wafer. The wafer is scribed into individual Blackwell die, tested and sorted, separating the good dies to move forward. The chip-on-wafer-on-substrate process attaches 32 Blackwell dies and 128 HBM stacks on a custom silicon interposer wafer. Metal interconnect traces are etched directly into it, connecting Blackwell GPUs and HBM stacks into each system and package unit, locking everything into place. Then the assembly is baked, molded, and cured, creating the Blackwell B200 superchip. Each Blackwell is stress tested in ovens at 125 degrees Celsius and pushed to its limits for several hours. Robots work around the clock to pick and place over 10,000 components onto the Grace Blackwell PCB. Meanwhile, custom liquid cooling copper blocks are prepared to keep the chips at optimal temperatures. At another facility, ConnectX-7 SuperNICs are built to enable scale-out communications, and Bluefield 3 DPUs to offload and accelerate networking, storage, and security tasks. All these parts converge to be carefully integrated into GB200 compute trays. NVLink is the breakthrough high-speed link that NVIDIA invented to connect multiple GPUs and scale up into a massive virtual GPU. The NVLink switch tray is constructed with NVLink switch chips, providing 14.4 terabytes per second of all-to-all bandwidth. NVLink spines form a custom blind-mated backplane with 5,000 copper cables connecting all 72 Blackwells, or 144 GPU dies, into one giant GPU, delivering 130 terabytes per second of all-to-all bandwidth, more than the global internet's peak traffic. From around the world, parts arrive to be assembled by skilled technicians into a rack-scale AI supercomputer. In total, 1.2 million components, 2 miles of copper cable, 130 trillion transistors, weighing nearly 2 tons. Blackwell is more than a technological wonder. It's a testament to the power of global collaboration and innovation, fueling the discoveries and solutions that will shape our future everywhere. We are driven to enable the geniuses of our time to do their life's work, and we can't wait to see the breakthroughs you deliver.
Grace Blackwell systems, all in production. It is really a miracle. It's a miracle from a technology perspective, but the supply chain that came together to build these GB200 systems, 2 tons each, we're producing them now 1,000 systems a week. No one has ever produced, mass-produced supercomputers at this scale before. Each one of these racks is essentially an entire supercomputer. Only in 2018, the largest Volta system, the Sierra supercomputer in 2018, is less performant than one of these racks. And that system was 10 megawatts. This is 100 kilowatts. So the difference generationally between 2018 and now, we've really taken supercomputing, AI supercomputing, to a whole new level, and we're now producing these machinery at enormous scales. And this is just the beginning. In fact, what you've seen is just one system, Grace Blackwell. The entire world is talking about this one system, clamoring for it to get deployed into the world's data centers for training and inferencing and generative AI. However, not everybody and not every data center can handle these liquid-cooled systems. Some data centers require enterprise stacks, the ability to run Linux Red Hat, or Nutanix, or VMware. Storage systems from Dell EMC, Hitachi, NetApp, vast, Weka, so many different storage systems, so many different IT systems, and the management of those has to be done in the way that's consistent with traditional IT systems. We have so many new computers to ramp into production, and I'm so happy to tell you that every single one of these are now in production. You haven't seen them yet. They're all flying off the shelves, flying off the ramps, the manufacturing lines, starting here. DGX Spark enables you to have essentially the Grace Blackwell system on your desktop. In the case of Spark, desktop. In the case of DGX Station, desk side. This way, you don't have to sit on a supercomputer while you're developing your software, while you're developing your AI. But you want the architecture to be exactly the same. These systems are identical from an architecture perspective. From a software developer's perspective, it looks exactly the same. The only difference is scale and speed. And then on this side are all the x86 systems. The world's IT organization still prefers x86 and appreciates x86. Wherever they can take advantage of the most advanced AI native systems, they do. Where they can't and they want to integrate into the enterprise IT systems, we now offer them the ability to do so. One of the most important systems, and it's taken us the longest to build because the software and the architecture is so complicated, is how to bring the AI native architecture and infuse it into the traditional enterprise IT system. This is our brand new RTX Pro server. This is an incredible system. The motherboard is completely redesigned. Ladies and gentlemen, Janine Paul. This motherboard looks so simple. And yet, on top of this motherboard are 8 Super NIC switches that connect 8 GPUs across a 200 gigabits per second state-of-the-art networking chip that then connects 8 of these GPUs and these Blackwell RTX Pro 6000 GPUs, brand new, just entered into production. 8 of these go into a server. Now, what makes it special? This server is the only server in the world that runs everything the world has ever written and everything NVIDIA has ever developed. It runs AI, Omniverse, RTX for video games, it runs Windows, it runs Linux, it runs Kubernetes in VMware. It runs basically everything. If you want to stream Windows desktop from a computer to your remote device, no problem. If you want to stream Omniverse, no problem. If you want to run your robotic stack, no problem. Just the QA of this particular machine is insane. The applications that it runs, basically universal. Everything the world's ever developed should run on here, including, if you're a video gamer, including Crysis. And so, if you can run Crysis, you can run anything. Okay, this is the RTX Pro server, brand new enterprise system. So something is changing. We know that AI is incredibly important technology. We know for a fact now that AI is software that could revolutionize, transform every industry. It can do these amazing things. That we know. We also know that the way you process AI is fundamentally different than the way we used to process software written by hand. Machine learning software is developed differently and it runs differently. The architecture of the systems, the architecture of the software, completely different. The way the networking works, completely different. The way it accesses storage, completely different. So we know that the technology can do different things, incredible things. It's intelligent. We also know that it's developed in a fundamentally different way. It needs new computers. The thing that's really interesting is, what does this all mean to countries, to companies, to society? And this is an observation that we made almost a decade ago that now everyone is awakening to. That in fact, these AI data centers are not data centers at all. They're not data centers in the classical sense of a data center, storing your files that you retrieve. These data centers are not storing our files. It has one job and one job only, to produce intelligent tokens, the generation of AI. These factories of AI look like data centers in the sense that they have a lot of computers inside, but that's where everything breaks down. How it's designed, the scale at which it's manufactured or scale designed and built, and how it's used, and how it's orchestrated and provisioned, operated, how you think about it. For example, nobody really thinks about their data center as a revenue-generating facility. I said something that everybody goes, yeah, I think you're right. Nobody ever thinks about a data center as a revenue-generating facility, but they think of their factories, their car factories, as revenue-generating facilities. And they can't wait to build another factory, because whenever you build a factory, revenue grows shortly after. You could build more things for more people. Those ideas are exactly the same ideas in these AI factories. They are revenue-generating facilities, and they are designed to manufacture tokens. And these tokens can be reformulated into productive intelligence for so many industries that AI factories are now part of a country's infrastructure, which is the reason why you see me running around the world talking to heads of states, because they all want to have AI factories. They all want AI to be part of their infrastructure. They want AI to be a growth manufacturing industry for them. And this is genuinely profound. And I think we're talking about, as a result of all that, a new industrial revolution, because every single industry is affected, and a new industry. Just as electricity became a new industry. At first, when it was described as a technology and demonstrated as a technology, it was understood as a technology, but then we understood that it's also a large industry. Then there's the information industry, which we now know as the internet. And both of them, because it affected so many industries, became part of infrastructure. We now have a new industry, an AI industry, and it's now part of the new infrastructure called intelligence infrastructure. Every country, every society, every company will depend on it. And you could see its scale. This is one that's being talked about a lot. This is Stargate. This doesn't look like a data center. It looks like a factory. This is 1 gigawatts. It will hold about 500,000 GPU dies and produce an enormous amount of intelligence that could be used by everybody. Well, Europe has now awakened to the importance of these AI factories, the importance of the AI infrastructure. And I'm so delighted to see so much activity here. This is European telcos building AI infrastructure with NVIDIA. This is the European cloud service providers building AI infrastructure with NVIDIA. And this is the European supercomputing centers building next generation AI supercomputers and infrastructure with NVIDIA. And this is just the beginning. This is in addition to what will come in the public clouds. This is in addition to the public clouds. So indigenous built AI infrastructure here in Europe by European companies for the European market. And then there's 20 more being planned. 20 more AI factories and several that are gigawatt gigafactories. In total, in just 2 years, we will increase the amount of AI computing capacity in Europe by a factor of 10. And so the researchers, the startups, your AI shortage, your GPU shortage will be resolved for you soon. It's coming for you. Now we're partnering with each country to develop their ecosystem. And so we're building AI technology centers in seven different countries. And the goal of these AI technology centers is, one, to do collaborative research, to work with the startups, and also to build the ecosystem. Let me show you what an ecosystem looks like. In the UK, I was just there yesterday, the ecosystems are built on top of the NVIDIA stack. So for example, every single NVIDIA, as you know, NVIDIA is the only AI architecture that's available in every cloud. It's the only computing architecture, aside from x86, that's available everywhere. We partner with every cloud service provider. We accelerate applications from the most important software developers in the world, Siemens here in Europe, Cadence, Red Hat, ServiceNow. We've reinvented the computing stack. As you know, computing is not just a computer, but it's compute, networking, and storage. Each one of those layers, each one of those stacks has been reinvented. Great partnership with Cisco, who announced a brand new model yesterday at their conference based on NVIDIA. Dell, great partnerships. NetApp, Nutanix, whole bunch of great partnerships. As I mentioned earlier, the way you develop software has been fundamentally changed. It's no longer just write C program, compile C program, deliver C program. It's now DevOps, MLOps, AI ops. So that entire ecosystem is being reinvented, and we have ecosystem partners everywhere. And then, of course, solution integrators and providers who could then help every company integrate these capabilities. Well, here in the UK, we have special companies that we work with, really terrific companies, from researchers to developers to partners to help us upskill the local economy and upskill the local talent, enterprises that consume the technology, and of course, cloud service providers. We have great partners in the UK. We have great partners in Germany. Incredible, incredible partnerships in Germany. We have great partnerships in Italy. And we, of course, have amazing partnerships here in France. That's right, go France. President Macron's going to be here later on. We're going to talk about some new announcements. So we have to show some enthusiasm for AI, okay? Yeah. There you go. Show him some enthusiasm. So great partnerships here in France. One particular one I want to highlight, our partnership with Schneider, building these AI factories. We build them digitally now. We design them digitally, we build them digitally, we operate them or optimize them digitally, and we will even eventually optimize them and operate them completely digitally in a digital twin. These AI factories are so expensive. $50 billion sometimes, $100 billion in the future. If the utilization of that factory is not at its fullest, the cost to the factory owner is going to be incredible. And so we need to digitalize and use AI wherever we can, put everything into Omniverse so that we have direct and constant telemetry. We have a great partnership here that we're announcing today. A young company, a CEO I really like, and he's trying to build a European AI company. The name of the company is Mistral. Today we're announcing that we're going to build an AI cloud together here to deliver their models as well as deliver AI applications for the ecosystem of other AI startups so that they can use the Mistral models or any model that they like. And so Mistral and us, we're going to be partnering to build a very sizable AI cloud here, and we'll talk about more of it later on today with President Macron. AI technology is moving at light speed. And what I'm showing you here, proprietary models on the left, moving at light speed. However, the open models are also moving at light speed, only a few months behind. Whether it's Mistral, Llama, DeepSeek R1, R2 coming, Q1, these models are all exceptional. Every single one of them exceptional. And so we've dedicated ourselves over the last several years to apply some of the world's best AI researchers to make those AI models even better. And we call that Nemotron. Basically what we do is we take the models that are open sourced. And of course, they're all built on NVIDIA anyhow. And so we take those models open sourced, we then post-train it. We might do neural architecture search. Provide it with even better data. Use reinforcement learning techniques. Enhance those models. Give it reasoning capabilities. Extend the context so that it could learn and read more before it interacts with you. Most of these models have relatively short context, and we want it to have enormous context capability because we want to use it in enterprise applications where the conversation we want to have with it is not available on the internet. It's available in our company. And so we have to load it up with an enormous amount of context. All of that capability is then packaged together into a downloadable NIM. You could come to NVIDIA's website and literally download an API, a state-of-the-art AI model. Put it anywhere you like. And we improve it tremendously. This is an example of Nemotron improvement over Llama. So Llama 8B, 70B, 405B, improved by our post-training capability, extension of reasoning capability, all the data that we provide, enhanced it tremendously. We're going to do this generation after generation after generation. And so for all of you who uses Nemotron, you will know that there's a whole slew of other models in the future, and they're open anyway. So if you would like to start from the open model, that's terrific. If you'd like to start with the Nemotron model, that's terrific. And the Nemotron models, the performance is excellent. In benchmarks after benchmarks after benchmarks, Nemotron performance has top of the leaderboard all over the place. And so now you know that you have access to an enhanced open model that is still open, that is top of the leader chart. And you know that NVIDIA is dedicated to this, and so I will do this for as long as I shall live, okay? This strategy is so good. This strategy is so good that the regional model makers, the model builders across Europe, have now recognized how wonderful this strategy is, and we're partnering together to adapt, enhance each one of those models for regional languages. Your data belongs to you. Your data belongs to you. It is the history of your people, the knowledge of your people, the culture of your people. It belongs to you. And for many companies, in the case of NVIDIA, our data is largely inside. 33 years of data. I was looking up this morning. Siemens, 180 years of data. Some of it written down on papyrus. Roland Bush is here. I thought I'd pick on Roland Bush, my good friend. And so you'll have to digitize that before the AI can learn. And so yeah, the data belongs to you. You should use that data, use an open model like Nemotron and all the tool suites that we provide so that you can enhance it for your own use. We're also announcing that we have a great partnership with Perplexity. Perplexity is a reasoning search engine. Yep. The three models I use ChatGPT, Gemini Pro, and Perplexity. And these three models I use interchangeably, and Perplexity is fantastic. We're announcing today that Perplexity will take these regional models and connect it right into Perplexity so that you could now ask and get questions in the language, in the culture, in the sensibility of your country. Okay, so Perplexity, regional models. Agentic AI. Agentic AI, agents, is a very big deal. As you know, in the beginning, with pre-trained models, people said, but it hallucinates. It makes things up. You're absolutely right. It doesn't have access to the latest news and data information. Absolutely right. It gives up without reasoning through problems. It's as if every single answer has to be memorized from the past. You're absolutely right. All of those things, you know, why is it trying to figure out how to add or count numbers and add numbers? Why doesn't it use a calculator? You're absolutely right. And so all of those capabilities associated with intelligence, everybody was able to criticize, but it was absolutely right because everybody largely understands how intelligence works. But those technologies were being built all around the world, and they were all coming together from retrieval augmented generation to web search to multimodal understanding so that you can read PDFs, go to a website, look at the images and the words, listen to the videos, watch the videos, and then take all of that understanding into your context. You could also now understand, of course, a prompt from almost anything. You could even say, I'm going to ask you a question, but start from this image. I could say, start from this text before you answer the question or do what I ask you to do. It then goes off and reasons and plans and evaluates itself. All of those capabilities are now integrated, and you can see it coming out into the marketplace all over the place. Agentic AI is real. Agentic AI is a giant step function from one-shot AI. The one-shot AI was necessary to lay the foundation so that we can teach the agents how to be agents. You need some basic understanding of knowledge and basic understanding of reasoning to even be able to be teachable. And so pre-training is about teachability of AI. Post-training, reinforcement learning, supervised learning, human demonstration, context provision, generative AI, all of that is coming together to formulate what is now agentic AI. Let's take a look at one example. Let me show you something. It's built on Perplexity, and it's super cool.
AI agents are digital assistants. Based on a prompt, they reason through and break down problems into multi-step plans. They use the proper tools, work with other agents, and use context from memory to properly execute the job on NVIDIA accelerated systems. It starts with a simple prompt. Let's ask Perplexity to help start a food truck in Paris. First, the Perplexity agent reasons through the prompt and forms a plan. Then, calls other agents to help tackle each step using many tools. The market researcher reads reviews and reports to uncover trends and analyze the competitive market. Based on this research, a concept designer explores local ingredients and proposes a menu complete with prep time estimates, and researches palettes and generates a brand identity. Then, the financial planner uses Monte Carlo simulations to forecast profitability and growth trajectory. An operations planner builds a launch timeline with every detail, from buying equipment to acquiring the right permits. The marketing specialist builds a launch plan with a social media campaign and even codes an interactive website, including a map, menu, and online ordering. Each agent's work comes together in a final package proposal, and it all started from a single prompt.
One prompt like that in the original chatbot would have generated a few hundred tokens. But now with that one single prompt into an agent to solve a problem, it must have generated 10,000 times more tokens. This is the reason why Grace Blackwell is necessary. This is the reason why we need performance and the systems to be so much more performant generationally. Well, this is how Perplexity builds their agents. Every company will have to build their own agents. It's terrific. You're going to be hiring agents from OpenAI and Gemini and Microsoft Copilot and Perplexity and Mistral, and there'll be agents that are built for you. And they might help you plan a vacation or go do some research, so on and so forth. However, if you want to build a company, you're going to need specialized agents on specialized tools and using specialized tools and specialized skills. And so the question is, how do you build those agents? And so we created a platform for you. We created a framework and a set of tools that you can use and a whole bunch of partners to help you do it. It starts with, on the very bottom, the ability to have reasoning models that I spoke about. NVIDIA's Nemotron reasoning large language models are world-class. We have Nemo Retriever, which is a multimodal search engine, semantic search engine, incredible. And we built a blueprint, a demonstration that is operational, that is essentially a general agent. We call it IQ, AIQ. And on top, we have a suite of tools that allows you to onboard an agent, a general agent, curate data to teach it, evaluate it, guardrail it, supervise, train it, use reinforcement learning, all the way to deployment. Keep it secure, keep it safe. That suite of toolkits is integrated, those libraries are integrated into the AI Ops ecosystem. You can come and download it from our website yourself as well, but it's largely integrated into AI Ops ecosystem. From that, you could create your own special agents. Many companies are doing this. This is Cisco. They announced it yesterday. We're building AI platforms together for security. Now, look at this. AI agents are not one model that does all of these amazing things. It's a collection, a system of models. It's a system of AI large language models. Some of them are optimized for certain type of things. Retrieval, as I mentioned, performing skills, using a computer. You don't want to bundle all of that stuff up into one giant, massive AI, but you break it up into small things that you could then deploy CI/CD over time. This is an example of Cisco's. Now the question is, how do you now deploy this? Because as I mentioned earlier, there are public clouds where NVIDIA's compute is. There are regional clouds, we call them NCPs. Here, for example, Mistral. You might have something that is private cloud because of your security requirements and your data privacy requirements. You might even decide that you have something on your desk. And so the question is, how do you run all of these? And sometimes they will run in different places because these are all microservices. These are AIs that could talk to each other. They could obviously talk to each other over networking. And so how do you deploy all of these microservices? Well, we now have a great system. I'm so happy to announce this for you. This is called our DGX Lepton. DGX Lepton, what you're looking at here, is a whole bunch of different clouds. Here's the Lambda cloud, the AWS cloud. Here's your own developer's machine. Your own system could be a DGX station, Nebius, Yoda, and Scale. It could be AWS, it could be GCP. NVIDIA's architecture is everywhere. And so you could decide where you would like to run your models. You deploy it using one super cloud, so it's a cloud of clouds. Once you get it to work, once you get this NIMS deployed into Lepton, it will go and be hosted and run on the various clouds that you decide. One model architecture, one deployment, and you can run it everywhere. You can even run it on this little tiny machine here. This DGX Spark, is it a cafe time? Look at this. This lift is 2,000 horsepower. This is my favorite little machine, DGX Spark. The AI supercomputer, we built an AI supercomputer in 2016. It's called the DGX-1. It was the first version of everything that I've been talking about. 8 Volta GPUs connected with NVLink. It took us billions of dollars to build. And on the day we announced it, DGX-1, there were no customers, no interest, no applause, 100% confusion. Why would somebody build a computer like that? Does it run Windows? Nope. And so we built it anyways. Well, thankfully, a young company, a startup, a nonprofit startup in San Francisco was so delighted to see the computer. They said, "Can we have one?" And I thought, oh my gosh, we sold one. But then I discovered it was a nonprofit. But I put a DGX-1 in my car, and I drove it up to San Francisco, and the name of that company is OpenAI. I don't know what the life lesson is there. There are a lot of nonprofits, you know. So next time, but maybe the lesson is this: if a developer reaches out to you and need a GPU, the answer is yes. And so that's right. So imagine you have Lepton. It's in your browser, and you have this Helm chart, an AI agent that you've developed, and you want to run it here. And parts of it you want to run in AWS, and parts of it you want to run, in a regional cloud somewhere. You use Lepton, you deploy your Helm chart, and it magically shows up here, okay? And so if you would like to run it here until you're done and ready to deploy it, and then deploy it into the cloud, terrific. But the beautiful thing is this architecture is based on Grace Blackwell. GB10 versus GB200 versus GB300, and all of these different versions but this architecture is exactly Grace Blackwell. Now this is amazing. So we're doing this for Lepton, but next, Hugging Face and NVIDIA has connected Lepton together. And so whenever you're training a model on Hugging Face, if you would like to deploy it into Lepton and directly into Spark, no problem. It's just one click. So whether you're training or inferencing, we're now connected to Hugging Face, and Lepton will help you decide where you want to deploy it. Let's take a look at it.
Developers need easy and reliable access to compute that keeps up with their work, wherever they are, whatever they're building. DGX Cloud Lepton provides on-demand access to a global network of GPUs across clouds, regions, and partners like Yoda and Nebius. Multi-cloud GPU clusters are managed through a single, unified interface. Provisioning is fast. Developers can scale up the number of nodes quickly without complex setups and start training right away with pre-integrated tools and training-ready infrastructure. Progress is monitored in real time. GPU performance, convergence, and throughput are at your fingertips. You can test your fine-tuned models right within the console. DGX Cloud Lepton can deploy NIM endpoints or your models in multiple clouds or regions for fast distributed inference. Just like ride-sharing apps connect riders to drivers, DGX Cloud Lepton connects developers to GPU compute, powering a virtual global AI factory.
DGX Cloud Lepton. Okay, so that's Cisco. This is the way SAP, they're building an AI platform in NVIDIA. Sana is building an AI business application automation on NVIDIA. DeepL is building their language framework and platform on NVIDIA AI. Photo Room, a video editing and AI editing platform, building their platform on NVIDIA. And this is Codo, used to be, I think, Codium, incredible coding agent built on NVIDIA. And this is Iola, a voice platform built on NVIDIA. And this one is a clinical trial platform, the world's largest automation platform for clinical trials built on NVIDIA. And so all of these basically builds on the same idea. NIMs that encapsulates and packages up in a virtual container that you could deploy anywhere, the Nemotron large language model, or other large language models like Mistral or others. We then integrate libraries that basically covers the entire life cycle of an AI agent. The way you treat an AI agent's a little bit like a digital employee. So your IT department would have to onboard them, fine-tune them, train them, evaluate them, keep them guardrailed, keep them secure, and continuously improve them. And that entire framework platform is called NEMO. And all of that is now being integrated into one application framework after another all over the world. This is just an example of a few of them. And then now we make it possible for you to deploy them anywhere. If you want to deploy it in the cloud, you got DGX, you got GB200s in the cloud. If you want to deploy it on-prem because you've got VMware or Red Hat Linux or Nutanix, and you want to deploy it in your virtual machines on-prem, you can do that. If you want to deploy it as a private cloud, you could do that. You're going to deploy it all the way on your DGX Spark or DGX Station, no problem. And so Lepton will help you do all of that. Let's talk about industrial AI. This is one of my favorite moments. This is Roland Bush. This is a really fun moment. He wanted to remind me that neural network computers were invented in Europe. That's this whole slide. It was such a great moment. This is the Synapse 1. This is incredible, you guys. Synapse 1. This is Synapse 1, 1992. It runs neural networks 8,000 times faster than CPUs at that time. Isn't it incredible? So this is the world's AI computer. And Roland just wants to, never forget that, Jensen. Never, ever forget that. I said, okay, all right. I'll even tell everybody. Siemens 1992. Siemens 1992. We have a great partnership with Siemens, and Roland Bush, the CEO, is supercharging the company so that they could completely leap the last IT industrial revolution and fuse the industrial capabilities of Europe, the industrial capabilities and might of Siemens with artificial intelligence and create what is called the industrial AI revolution. We're partnering with Siemens on so many different fronts. Everything from design to simulation to digital twins of factories to operations of the AIs in the factories, everything from end to end. And it just reminds me how incredible the industrial capabilities of Europe is, and what an extraordinary opportunity this is for you. What an extraordinary opportunity, because AI is unlike software. AI is really, really smart software. And this smart software can finally do something that can revolutionize the very industries that you serve. And so we made a love letter video, if you will. Let's play it.
It began here. The first industrial revolution. Watt's steam engine and the mechanized loom introduced automation and the advent of factories, and industry was born. The age of electricity. Ampere unraveled electromagnetism. Faraday built the first electric generator, and Maxwell laid the foundations for modern electrical engineering. Siemens and Wheatstone's dynamo, the engine of electricity, bringing machines, trains, factories, and cities to life, electrifying the planet, igniting modern manufacturing. And today, born out of the computing and information age, the fourth industrial revolution, the age of AI, reimagining every part of industry. Across the continent, industrial AI is taking hold. From design to engineering, you're blazing new trails toward understanding and reinvention. You brought the physical world into the virtual. to plan and optimize the world's modern factories. You're building the next frontier, where everything that moves is robotic. Every car, an intelligent autonomous agent, and a new collaborative workforce to help close the global labor shortage gap. Developers across the continent are building every type of robot, teaching them new skills in digital twin worlds and robot gyms, preparing them to work alongside us in our factories, warehouses, the operating room, and at home. The fourth industrial revolution is here, right where the first began.
What do you think? I love that video. You made it. That's so great. You made it. Well, we're working on industrial AI with one company after another. This is BMW building their next generation factory in Omniverse. This is, I don't know how to say it. Can somebody teach me? Bujes? Sounds good. Exactly. That's exactly right. Good job. Good job. That's exactly right. They're building, of course, their plants, digital twins in Omniverse. This is Kion, their digital twin for warehouse logistics. This is Mercedes-Benz and their digital twins of their factories built in Omniverse. This is Schaeffler and their digital twin of their warehouse built in Omniverse. This is your train station here in France, building a digital twin of their train stations in Omniverse. And this is Toyota building a digital twin of their warehouse in Omniverse. And when you build these warehouses and these factories in Omniverse, then you could design it, you can plan it, you can change it. In greenfield is wonderful, in brownfield is wonderful. You could simulate its effectiveness before you go and physically lift and move things around to discover it wasn't optimal. And so the ability to do everything digitally in a digital twin is incredible. But the question is, why does the digital twin has to look photoreal? And why does it have to obey the laws of physics? The reason for that is because we wanted ultimately to be a digital twin where a robot can learn how to operate as a robot. And robots rely on photons for their perception system. And those photons are generated through Omniverse. And robots needs to interact with the physical world so that it could know whether it's doing the right things and learn how to do it properly. And so these digital twins have to look real and behave realistically. Okay, so that's the reason why Omniverse was built. This is fantastic. This is a fusion reactor digital twin. Incredibly complicated piece of instrument, as you know, and without AI, the next generation fusion reactor would not be possible. Well, we're announcing today that we are going to build the world's first industrial AI cloud here in Europe. I'm going to announce, yep. These industrial AI clouds are, yes, a whole lot of computers in the cloud. However, its requirement, its performance, its safety requirements fundamentally different. And so I'm going to tell you a lot more about it on Friday. I'm only teasing you part of the story today, but this industrial cloud will be used for design and simulation, virtual wind tunnels that you just walk into. Virtual wind tunnels you just move a car into and you see it behave. Open doors, open windows, change the design, all completely in real time. Design in real time, simulate in a digital wind tunnel, digital twin of a wind tunnel in real time, build it in a factory of a digital factory, digital twin in real time, all of this, and let robots learn how to be great robots and build the robots of our future. Self-driving cars and such. We already have tremendous ecosystem here. We've been here, as you know, for a very long time. NVIDIA is 33 years old. The first time we came to Europe was during the time when workstations and the digitalization of products, CAD, the CAD revolution started. We were here doing the CAE revolution, and now the digital twin revolution. Some $2 trillion of ecosystem here in Europe that we partner with and that we have the privilege of supporting. What comes out of that is a new revolution that's happening. As you know, everything that moves will be robotics. Everything that moves will be AI driven. And the car is the most obvious next one. NVIDIA builds the AI supercomputers to train the model. The AI supercomputer for Omniverse digital twins. We also build the AI supercomputers for the robots itself. In every single case, whether it's in the cloud, for Omniverse, or in the car, we offer the entire stack. The computer itself, the operating system that runs on top of this computer, which is different in every single case. This computer, high speed, sensor rich, must be functional safe. In no circumstance could it fail completely. And so the safety requirement's incredibly high. And now we have an incredible model that sits on top of it. This model that sits on top of it is a transformer model. It's a reasoning model, and it takes sensor in, you tell it what you want it to do, and it will drive you there. Takes pixels in, and it generates path plans output. So it's a generative AI model based on transformers, incredible technology. NVIDIA's AI team, AV team, is incredible. This is the only team that I know that has won end-to-end self-driving car challenge at CVPR 2 years in a row. And so they're the winner again this year. Let's take a look at the video. Yep, thank you.
Like any driver, autonomous vehicles operate in a world full of unpredictable and potentially safety-critical scenarios. NVIDIA Drive, built on the Halo safety system, lets developers build safe autonomous vehicles with diverse software stacks and sensors and redundant computers. It starts with training. Safe AVs need massive amounts of diverse data to be able to address edge cases. But real-world data is limited. Developers use NVIDIA Omniverse and Cosmos to reconstruct the real world and generate realistic synthetic training data to bring diversity to the AV model. The model can perceive and reason about its environment, predict future outcomes, and generate a motion plan. And for decision-making diversity, an independent classical stack runs in parallel. Guardrails monitor safe performance, and in cases of anomalies, calls the arbitrator to make an emergency stop. Further diversity and redundancy are built into the sensor and compute architecture. Each sensor connects to redundant computers. So even if a sensor or computer fails, the vehicle stays safe and operational. And in the event of a critical failure, the system can execute a minimum risk maneuver, like pulling over to the shoulder. Safety is foundational to autonomous driving. NVIDIA Drive lets developers worldwide integrate Halos into their own products to build the next generation of safe AVs.
A billion cars on the road, 10,000 miles a year on average, 10 trillion miles. The future of autonomous driving is obviously gigantic, and it's going to be driven, it's going to be powered by AI. This is the next gigantic opportunity, and we're working with enormous companies and really fantastic companies around the world to make this possible. At the core of everything we do here with AV is safety, and we're really, really proud of our Halo system. It starts with the architecture of the chip, and then the chip design, and the systems design, the operating system, the AI models, the methodology of developing the software, the way we test it, Everything from the way we train the models, the data we provide for the models, all the way to the way we evaluate the models. NVIDIA's Halo system and our AV safety team and capabilities are absolutely world-renowned. This computer was the first one to be software-defined. The world's first software-defined, completely 100% software-defined AI-driven software, AI-driven stack for AVs. We've been at this now for coming up on 10 years. And so this capability is world-renowned, and I'm really proud of it. The same thing that's happening for cars is happening for a new industry. As I mentioned earlier, if you can generate video from prompts, if AI can perceive, it can reason, and it can generate videos and words and images, and just now with cars, the path, the steering wheel path, why can't it also generate locomotion abilities and articulation abilities? So that fundamental ability for AI to revolutionize one of the hardest robotics problems is around the corner. Humanoid robots are going to be a thing. We now know how to build these things, train these things, and operate these things. Humanoid robotics is going to potentially be one of the largest industries ever. And it requires companies who know how to manufacture things of extraordinary capabilities. This speaks of the European countries. So much of the world's industries are based here. I think this is going to be a giant opportunity. Well, let's say it's 1 billion robots around the world. The idea that there'll be 1 billion robots is a very sensible thing. Now, why hasn't it happened? Well, the reason for that is simple. Today's robots are too hard to program. Only the largest companies can afford to install a robot, get it to teach it, program it to do exactly the right things, keep it sufficiently surrounded so that it's safe. That's the reason why the world's largest car companies all have robots. They're large enough, the work is sufficiently repetitive, the industry is at a sufficient scale that you could deploy robots into those factories. Almost everybody who's a Mittelstand or small, medium companies or mom and pop restaurants or stores or warehouses, it's impossible to have that programming capability until now. We're going to give you essentially robots where you could teach them. They'll learn from you. Just as we were talking about agentic AI, we now have humanoid AI that can learn from your teaching using toolkits that are very consistent with the NEMO toolkits I spoke about. NVIDIA here as well is built in 3-layer stack. We build the computer, the Thor computer. Dev kit looks a little bit like this. This is a robotic computer, completely self-contained. Dev kit sits on your desk. These are all the sensors. And inside is a little supercomputer Thor chip. Just really, really incredible. And these, yep. Yeah. I could imagine getting one of these inserted like that. Okay. Thank you, Janine. And so that's the Thor processor. On top is an operating system designed for robotics, and on top of that, transformer models that take sensor and instructions and transforms it and generates flight or paths and motor controls for arm articulation, finger articulation, and of course, your legs articulation. Now, the big challenge of humanoid robotics is the amount of data necessary to train it is very, very hard to get. And so the question is, how do you do that? Well, the way you solve that problem is to back in Omniverse, a digital twin world that obeys the laws of physics. And this is an incredible piece of work that we're doing. Don't do it. Don't. Oh, my fault. Okay, these are robots. We develop computers to simulate, to train them, computers to simulate them, and the computer that goes inside them. There's a whole bunch of human robotics companies being built around the world. They all see the great opportunity. to revolutionize this new device, if you will. And the progress is going incredibly fast. And the way that they all learn is they learn in a virtual world. And this virtual world has to obey the laws of physics. And recently, we announced a big partnership with Disney Research and DeepMind. And we're going to work together to create the world's most sophisticated physics simulation. And I'm just trying to figure out, at this point, how to go to that slide. Teach me. Who's with me? This is what happens when you only rehearse once. Okay, so this incredible system is where an AI learns how to be an AI. Let me show it to you. We have a special guest. Your name is Greg. Are you a petite garçon or petite fille? Okay. Greg is a little girl. Now, look at this. Greg learned how to walk inside Omniverse, obeying the laws of physics. And by inside Omniverse, we created hundreds of thousands of scenarios. Then finally, when Greg learned how to operate and walk and manipulate in those environments on sand and on gravel, on slippery floors, on concrete, on carpet, then when Greg comes into the physical world is just 100,001 version of the world. And so you learn how to walk in the virtual world, and look at you now. Can you jump? Wow. Can you dance? Well, I just want to let you know, I am the keynote presenter. So I need you to behave. I need you to behave for a few seconds. Could you sit? Sit. Hey, you know what we should do? Let's take a picture of everybody. Yeah. Bam, bam. Would you like to come home with me? Would you like to come home with me? Yeah, I know. Yeah, I have pets. They would like to have you as a pet. No? No. You're so smart. You're so smart. Wow. Incredible, right? You are the world's best robot, and someday we'll all have one like you, and they'll follow us around. But if I need a glass of whiskey, you're going to have to go tell somebody else to go get me a glass of whiskey because you have no arms. Yeah, you're so cute. Okay, little girl, you stay here for a second. Let's wrap up. All right. It's very clear an industrial revolution has started. The next waves of AI has started. Greg is a perfect example of what's possible now with robotics. the technology necessary to teach a robot, to manipulate, to simulate, and of course, the manifestation of an incredible robot is now right in front of us. We have physical robots, and we have information robots. We call them agents. So the next wave of AI has started. It's going to require inference workloads to explode. It's basically going to go exponential. The number of people that are using inference has gone from 8 million to 800 million, 100 times in just a couple of years. The amount of prompts that the tokens generate, as I mentioned earlier, from a few hundred tokens to thousands of tokens. And of course, we use AI even more than ever today. So we need a special computer designed for thinking, designed for reasoning, and that's what Blackwell is, a thinking machine. These Blackwells will go into new types of data centers, essentially AI factories, designed for one thing and one thing only. And these AI factories are going to generate tokens, and these tokens are going to become your food, little Greg. Yeah, I know. And what's really, really incredible, I'm so happy to see that Europe is going all in on AI. The amount of AI infrastructure being built here will increase by an order of magnitude in the next couple of years. I want to thank all of you for your partnership. Have a great Viva Tech. Thank you. Say bye-bye. Say bye-bye. Take a bunch of pictures. Take a bunch of pictures. Take a bunch of pictures. Yeah?
Wow. I don't know.
Alrighty, how are we all doing? Is everyone still there?
Yeah, we are still here, Fatma. Can you hear me? Hello.
Hello, everyone.
Hello.
Fatma, we can hear you, and we can hear the room. Can you hear us?
Hello.
Hello. Yeah, sorry, I was on mute.
Okay.
How's everyone doing? How did they find the session? Fantastic, fantastic. So this brings us to the end of today's session. As I mentioned, we will share all the documents with regards to getting access to the free DLI courses. Thank you so much again to Qhala, specifically Shiko, IT, and Luisa. I don't know how to pronounce the name. Do forgive me, Madam Oma. But thank you guys so much for joining us today. Looking forward to our next coming sessions with Qhala. Do stay tuned as we continue to flesh out this partnership. Have a wonderful day, but also happy to stay on for another 10 minutes just to wrap up in case anyone has question, feedback, or what they want to see next before we head off to our next session. So over to the audience.
So, hi everyone. So if you have any questions for Fatima or any questions to regards the watch party, you have the floor is yours. So I can just pass over the mic. If you have any questions.
Hi, my name is Helena. Thank you. That was very, very, very informative. I've been out of the IT sector for a while, so jumping back in, this has been great. My question is there any way I can get the QR code for the free classes?
Absolutely.
And keep up the good work.
Thank you so much for joining. So happy that this is the way that you're being reintroduced into the industry. Did anyone want to share any highlights? What were the top 3 announcements that you were excited to hear? How do you think we can replicate or tailor some of the information that we heard today to the African context?
Hello. So we have a couple of questions on the live audience. So I want to give it to one of the audience members.
Wonderful.
Joseph, switch on the camera. Okay, thank you.
Hi, Fatima. My name is Denson. So the question for me is, what's in store for Africa? So I know he's in Europe right now, so the conversation was largely centered around Europe. But what do you guys have in store for us as Africa?
Absolutely. So the earlier GTC that we had in March in San Francisco, we announced that Africa is working on its first data center. The first data center will be launched in the upcoming months in South Africa by Cassava. So I'm not sure whether anyone has seen that in announcement. The other things as well that we're working on Africa is really the developer base. So a lot of our focus right now is around developers, because we believe if we have strong developers, enterprise, education, and startups are able to innovate. So that's how we're focusing and thinking about Africa. So hopefully the next GTC in the coming years will be on the continent. And we have like lighthouse accounts in northern block of Africa. We found a lot of success in the Moroccos and in the Tunisias.
Amazing. Thank you so much, Fatima, for that. Any other questions or comment?
Good afternoon, everyone. My name is Joan. My question goes to the second point, that is you focusing on the developer education. Do you maybe provide more clarification on that? How are you looking forward in terms of like partnerships, or are you setting up developer education schools? Or yes, what's your focus? Could you please provide more information on that? Yeah.
Absolutely. Thank you so much for that question. It's a really, really good question. So when we think about developer enablement, as I shared earlier in the slide, we have 4 key touch points. The first touch point is our Deep Learning Institute. Our Deep Learning Institute can also be looked as an online academy. On our Deep Learning Institute, we have more than 80 different courses. Some of these courses are complimentary and some of these courses are paid for. So in the case of Africa, what we do is we partner with different organizations such as Qhala, the Andellas, the Go My Codes, and we work with communities to get them enabled on AI education so that they're able to go into different fields and implement that learning. The other thing that we also really focus on is university, because we've realized that in order to scale, we need to work with universities with redesigning or rethinking their curriculum as it pertains to AI. So what we do is we have an ambassador program where faculty members at universities can go through a 3-month certification process. And when they're able to do that, university professors are then able to request for Deep Learning Institute vouchers for free for their students. Now, the reason why Deep Learning Institute vouchers are really important is because to the panelists earlier before, as they mentioned, we need to move away from theory and to practice. The Deep Learning Institute provides you with an environment where you're able to test your AI solutions. It provides you with complementary cloud credit, and it also provides you with sandbox environments. That's why the Deep Learning Institute is super important. And to end that question again, I think when, at least from the global stage, when they're looking at countries to invest in, regions to invest in, it all starts with how many active developers are there. So in order to get Africa to, I guess, have the same level of attention on it, it really depends on how many developers are there. Because if we're bringing in infrastructure and we don't have adequate developers, then it becomes a chicken and egg problem. I hope that answers the question.
Yeah, that's really helpful. And not to toot my own horn, I'm an NVIDIA DLI ambassador. So yeah, you can.
That's good to hear. Very, very good to hear.
So any other questions? Okay, we have a few questions online. So Catherine, you can go.
Hi, it's not Catherine. I'm just using Catherine's computer. So my name is Jennifer. I work with Mtoto News and Kutunga. My question is, how child sensitive are these platforms? I was watching that robot and it took me to a movie. Is it E.T. or is a movie that has that character, like to the T, even the talking. So my question is, because in fact, I'm going to be speaking in a conference in the next 30 minutes, and we're talking about chatbots and children. So NVIDIA, how have you incorporated, one, safety by design principles, and number two, they just launched AI, child sensitive principles into these programs? Because in reality, all these guys who are watching here are not the ones who are using these platforms. It's kids who are using these programs. They're not who are using these softwares. Even if you've been told it's not a software. How are you involving children? How are children's voices being included? And how sensitive are these? Thank you.
Thank you so much for your question, Catherine. I can speak to around safety by design as it pertains to children programs. Unfortunately, that's outside of my scope of expertise. But when we talk about safety by design, again, I think in the previous panel, they spoke about trustworthy AI. And trustworthy AI is a team that we have, and they ensure that everything that we put out into the ecosystem goes through rigorous legal scrutiny, it goes through safeguardings and so forth. So we have, for example, a NEMO guardrail, which is a little bit different from robotics. The NEMO guardrail was designed for LLMs. So essentially what you can do is, let's say you're creating a chatbot and you don't want it to respond to certain prompts, or you don't want it to say certain words, you can code that into the LLM that you're doing. So that's an example of safeguarding.
Okay, sorry. You just said that, so the LLM itself is not, does not have the safety by design. It is the designer who is supposed to code it into it.
So again, just to kind of go back to the background, NVIDIA doesn't create LLMs. We power different organizations to create LLMs. So in doing that, we can then provide a guardrail for developers who want to make sure that their LLMs are safe for children. And I'm happy to put this in the chat as well, just so that you can learn more about it, because for the sake of time, we want to make sure that we can answer other questions, because unfortunately, I have a hard stop in 10 minutes.
Okay, thanks, Fatima, for that. Anyone else online, you can just raise your hand and then we can be able to see, to take a couple of more questions online. On the physical audience, any further questions or comments? Okay, we have one more.
Hi, Fatima. Thank you so much for pulling us through this watch party. And thank you also to Qhala. My name is Dennis Kere, a tech researcher from GTRCMC and also at BYB Incorporation. So BYB deals with gaming. I'd like to ask, since I was a child, I was looking forward for a computer which has an NVIDIA GeForce, sticker. So I'm happy to be also part of the game and also contributing as well. So I'd like to ask about the gaming industry in Africa and especially Kenya as well. Are you, do you have some leads on that, the gaming thing?
Yes and no. So again, I sit under the developer programs, unfortunately, so I'm not as exposed to the gaming sector. But when it comes to gaming, what we do is we provide different tools for developers, more so for the gamer itself. So I'm just curious to know, are you asking as a gamer or are you asking as a video game developer?
I'm asking for both.
Okay, so I can speak to the video game developers. As I mentioned earlier in the call, we have different SDKs, and we have SDKs and libraries for gaming developers. We have a program as well called Inception, where we have about 29,000 startups. In Africa, we have about a dozen startups focused on gaming. And I think about 2-3 years ago, we actually did a write-up on the different startups, such as Carry First, Lechi Arts, and so forth. So in the chat, I will share a link to it so that you can read a little bit more about the gaming elements. And then I'll share some resources with regards to how you can get involved. In terms of communities, we've seen them be more active in North Africa and the southern parts of Africa.
Thank you for that response. And a follow-up question is, how about like accessing the Omniverse?
Yes, that's a great question. So again, in terms of accessing Omniverse, you can actually access it in its beta form right now, and you can do it complimentary. Once you sign up for the course, it will make you sign up for NVIDIA's developer programs. Within the developer programs, you automatically get access to all our different resources, and that includes Omniverse. So there's like a trial kit and a virtual environment for Omniverse. And that, like, you know, in the keynote, we spoke a lot about digital twins.
Cool. Thank you so much for that question. So I'm going to pick the last two questions, and then I'm going to invite Dr. Shiko to give us the vote of thanks, and then we'll end. So,
Great. Mine is not a question, it's a follow-up to the, of course, conversation of training developers. I do run an organization where we train developers, and I'm wondering what it takes in terms of partnership, what are things that you're looking for, and of course, how we can do this partnership together.
That's a great question. Thank you so much for that. So I think in terms of partnerships, what we typically look at when it comes to Africa in order to do it sufficiently is a developer base that has some level of background in artificial intelligence or data science. It makes it really helpful to bridge the gap. So typically we're looking for skills in Python. CUDA can sometimes be a little bit advanced, but we believe that when developers have some understanding of basic Python and data science, then we're able to work with them. In terms of the way that we go about partnering with people, typically we work with organizations who are able to scale. So when we talk about scaling, we're either looking at organizations where you have faculty members, and faculty members are able to go into universities and scale, or organizations where they have developers, usually a minimum of 100 developers. In order to upskill them, we upskill them through our Deep Learning Institute, where we have different courses that focus on different use cases. So before as well, there was a lot of conversation around Jetson. And when we look at Kenya, well, edge computing rather. And when we look at Kenya, a lot of the use cases that we see are typically around LLMs in Kiswahili, or using edge computing for agriculture. So these are some of the things that we look at. So what is the community trying to achieve? Are you trying to upskill developers? Are you trying to upskill students? How are you trying to achieve it? Are you doing it through hackathons? Are you doing it through masterclasses? And what's the timeline in which you're trying to do it? If we feel like the community perhaps isn't the right fit at the moment, what we can then do is we can share virtual and online resources that we have until we're able to scale with them.
Thanks so much, Fatima. My name is Elvira Omondi. I'm the head of programs here at Qhala. I'm really glad and happy about this great session that we've had today. I'm very sure everybody here has benefited. I'm just curious to know how we at Qhala could tap into your innovation programs so as to be able to upskill startups and also other partners that you're working with within this ecosystem. We could have that maybe say idea now, but maybe this is something that we'll also take further into further discussions beyond this gathering today. Thank you so much.
That's a great question. At the end of the session, I'll send a partnership guide. It's extremely extensive, and feel free as well to share with the rest of the audience. There's about 32 pages in it. And in the partnership document, it talks a lot about FAQs, how to partner, and different resources for different personas. So when it comes to the persona of a startup founder, the Inception program will be the best way to go. If you happen to be a faculty member or a researcher at a university, then the ambassador program is the best way to go. And if you happen to be a researcher, then the developer programs is also a really good resource. Within the developer programs, from time to time, we have call for applications for grants that we honor. The grants that we usually honor are typically in the form of compute. But again, we have a comprehensive document outlining all of this. I'll share it with you, and feel free to share with the rest of the audience so everyone can take their time to digest it and figure out the different ways that they can plug into the NVIDIA ecosystem. But again, the first step would be the Deep Learning Institute, because when you sign up for the Deep Learning Institute, you automatically become what we call an NVIDIA developer. And when you become an NVIDIA developer, when you're signing up, it'll typically ask you, where are you working? What's your persona? What are you trying to get a better understanding of? And then we send personalized recommendation on how best for you to leverage our ecosystem.
Thank you so much, Fatma, and thank you so much to the audience for the great questions. And we are now going to move to the just a reminder of the next steps. So we're going to take a group photo. So we're going to take a group photo immediately after the vote of thanks. So we're going to take it here so that also those online can also be represented. And yeah, and also please remember to sign up in the sign up form so that we can be able to send you the free courses from NVIDIA for the attendees of this event. So if you haven't signed up yet, please kindly sign up. So if you haven't signed up, reach out to me or any Qhala member will be able to assist you with that. So I'm going to invite Dr. Shiko to give the vote of thanks and the final remarks. Dr. Shiko.
Thank you. Thank you very much, everyone, for being part of this. I remember when you were talking with Fatma about pulling this together, it felt, yeah, as a big challenge, and we love big challenges. We do hard things at Qhala. So I'm really excited about this. As I was watching the video, I was thinking, oh my, the keynote, I was thinking, oh my God, I want a small robot for myself to do everything I want, but also I don't want a small robot because I want to remain human. So it is that balance of what that looks like. But on the other hand, it's the question that each one of you has asked today is, what does this mean for Africa? I mean, everybody gets excited. I got so many DMs on LinkedIn, on WhatsApp, people, everybody saying this is very exciting, but what is it in it for Africa? Where will Africa benefit? So I'm excited to announce that Fatma kept talking about the resources that they are going to channel through Qhala. I don't know if Riaz is here. I'm really excited to mention that in the next 6 weeks, we are going to be launching a Qubit Hub. We already have Qubit Hub as a virtual space, but you're going to be launching a physical space together with Angani. Angani is the cloud computing team, where we are going to be providing a few of these resources that you're talking about, with, of course, NVIDIA providing the resources they've mentioned about. Angani is going to be providing, we are going to have a physical space where you can come and work. And hopefully by the end of the year, we're going to provide some compute that you can actually afford, because the questions that came up in the panel earlier on, and even during the initial presentation around compute, actually big ones. And how can we solve it for researchers? As Fatma mentioned, we need to demonstrate that there's demand on the continent, but we cannot just wait for the demand to come by itself. We have to catalyze it. And our goal is to be able to create curiosity around AI from a developer point of view, from a research point of view, but also create an enabling environment that these researchers actually can be able to work, and startups and developers like yourselves are able to work. So we're really excited about that. Again, sign up. We'll be sharing this information and more, and we're on the direction to the hub. So you don't come to Qhala. It's not going to be in Marsabit Plaza. We are going to be sharing this information and how to sign up. It's going to be a rigorous process to be a member. It's going to be free, but rigorous process to be there, because we want to have high quality talent coming through the hub. Thank you very much again for coming. Thank you for the Qhala team who are on the ground and running this, and the Qhala team that is everywhere in the world who woke up really early, or actually in the middle of the night, to be part of this conversation. Thank you, Fatma and your team, for believing in us and believing that Africa can, and we can actually build AI. Thank you, everyone. Have a nice day. Take some coffee and tea and mandazis. I'm sure you have mandazis and samosas. Enjoy the rest of your day. Bye-bye.
Thank you guys so much. Asante. Bye.
Thank you so much, Dr. Shiko. So I'm going to pass these now to our photo man so that he can guide us on how we can look pretty and smile. So we just come over here and then we can take a picture.
The front. Let's move to the front. Seats. We'll have a row of seats first, and then everyone else at the back. Yeah. Okay. So just 2-3 minutes, and then yeah, can take the rest of the time to network.
So the tallest guy is at the back, standing at the back, and then there's seats as well for anyone who wants a seat. So everyone, let's move to the front. To the end of it. So at the end of the screen, so this is our frame. The end of the screens are our frames. And we'll need to move these ones as well so that we can have at least some. Yeah.
You'll understand if you take my hand and we listen to the radio. Oh, listen to the radio. Let's spend the night together, baby, don't go. They sing it on the radio. I try to find a way to explain to you what's on my mind and not sound so plain to you.
Team online, if you can put your screens on.
If you close your eyes, feelings my words can't show. They're playing on the radio. Listen to the radio. Oh, listen to the radio. Let's spend the night together, baby, don't go. They sing it on the radio. The words I'd say don't seem to sound as real. The songs they play, that's how I really feel. So listen to the radio. Oh, listen to the radio. Let's get the night together, baby, don't go. They sing it on the radio. Listen to the radio. Oh, listen to the radio. Let's spend the night together, baby, don't go. They sing it on the radio. I don't know if you can don't have like a direct contact to her. That's a neon.
It's okay. It's ready to
Okay. There's a million earthquakes pumping that black gold all over the world. Chicks and cowboy billionaires and limousines loaded with sparkling pearls. Money can't buy happiness. Just listen to the stories they tell. All you need to really succeed in life is one good well. It takes a one well, deep and ever flowing. One well, all from night and day. Yours and mine, it's yours and mine, and it's always enough. We got one well going with an everlasting fire. Don't it seem kind of funny how people with a lot of money only hunger for more? Think that money can burn.